Hello, welcome to another stream. How about that? How about that? Welcome, welcome. Today is Tuesday, if I'm not mistaken. Yes, today is Tuesday. Finally, the second day of the week. Hello, here Hudson Blots, Dr. Puppy, I good Duke, Mr. Botka, Copper Casted Sintus, I good Duke, Ford. Hello, thank you, PS Comp Psy for subscription, for Twitch Prime subscription, your first subscription, by the way. And welcome to our epic virtual machine club. Serious Sergio, hello, Libra, welcome, Aunt Rax, Clean Walrus, John, hello. I didn't see anyone else. I am 8051. No IO before bedtime. Hello. Welcome. Cerimon. Hello. So today is Tuesday, and today, according to the schedule, according to updated schedule, by the way, because I updated it before the stream, we continue to develop our virtual machine. Hello, Terrible Goss. I hope I pronounced your nickname correctly. So yeah, yesterday we started to develop a virtual machine for our Lisp. It's called BM. And it went quite well. We managed to implement a virtual machine that is capable of arithmetic operations, basic arithmetic operations. It has a stack, so it's a stack machine, and also it has looping and branching, which effectively makes it probably Turing complete, but we never proved that. So to prove that it's Turing complete, we need to implement one of these Turing complete games, like Game of Life or Rule 110. I think this is how it's called. Something like Rule 110 should be super easy to implement, but I'm not sure how to do that on our machine yet. We'll see. So today we're gonna continue developing these things. So I have a couple of issues planned for today, so I'm gonna follow my plan, and then we'll see what next we're gonna have. I also came up with the logo for this for this virtual machine. So the name of virtual machine is BM. It's a virtual machine. Yes. Anyway, so I think my kettle is ready, so I'm gonna go and brew some tea, and then I'm gonna get back. Don't go anywhere, or as usual, you're gonna get banned. So yeah, cute logo. I drew it myself, by the way. I stole idea from other Birch logos, though. Like I actually drew it myself. fucking coming. Okay, what's up? What's up? What's up? Looks like a big smoke stack. Exactly. That's what it is. What's up, Tsoding2S? Hello, hello. Virtual machine. Yeah, like the idea of these like stripes, it's actually stolen from some of the logos, but I did in fact made it from scratch myself in Inkscape. There is assets here, and there's even like original SVG. There's original SVG, so we can actually scale it, you can recolor it, and I think I'm gonna release it at under Common Creatives, but I didn't decide which one. Oh, we have a raid from Dennis. Thank you so much for the raid. And raiders, welcome to our virtual machine development. We're not developing like, you know, virtual box or QEMA virtual machine. We're developing the language virtual machine, similar to like, God forbid, JVM. But I mean, it's actually a quite common exercise in computer science to develop these small language virtual machines. And that's what we're doing. So we're actually developing a virtual machine. I couldn't come up with a better name, so I'm sorry. It's a virtual machine called BM. There's actually a lot of lore behind this name, so I'm just too lazy to explain. Hello, Tietanasa, hello, Herzenplots, Marian G, Major Lift, hello. Welcome. Alright, bye-bye, Dennis. See you around. So yeah, virtual machine. We're developing a virtual machine. I mean, because it's with T, because it's like virtual with V replaced with B. So I don't know. I don't think it matters that much. I just needed some sort of a name, and I just needed some sort of a logo. I think we're reading too much into that. All right. Okay. So is that? Yeah, I wanted to actually see you there. So let's fetch the latest stuff. I think I cleaned up the source code a little bit right before the stream. Yes, I did a little bit of work off screen. Specifically, I didn't do anything special. Well, I edited the logo first of all, as you can see. I just edited the logo. Logo is there in the source code. And also turned BM, the library itself, into a header-only library in STB style. Right, in STB style. So according to STB style, if you include this library, you're only gonna include declaration, you're not gonna include definitions, right? So, and to include definitions, you also need to put BM implementation there. So if you go to one of our executables here, right, so something like BMI or BUSM, so this is how you're supposed to include this virtual machine. So imagine like having header-only library virtual machine. Language virtual machine. So this is what I'm actually striving for. So you do BM implementation, you just include this machine, then you create the machine in a static memory, you initialize everything, and in this particular case we're just compiling this the assembly to the bytecode. In case of BMI, we're actually interpreting everything. Right, so in case of BMI, as you can see, we just load the program from the file, then we are iterating. Okay, this one is actually kind of strange, so we'll probably have to come up with like a special instruction here instead. So this is going to be a to-do, introduce BM execute program, right? So this is what we need to, so we have a BM execute instruction and the next instruction, and we need to have BM execute program that basically indefinitely just implements this loop for you, so you don't have to do that yourself, right? So this is one of the things that we're gonna have here. All right. So what do we have planned for today? Nothing special. I just outlined a couple of issues that I wanted to address, specifically for assembly language. By the way, for those who doesn't know, we even have an assembly language. Right, we have two file formats. So first is the assembly language itself. Right, so you can program this virtual machine in this assembly language, and then you can compile it into the binary, right? Into the binary that you can then execute, and with our special simulator or emulator rather. So, and I want to add a couple of things to this, to both assembly and the bytecode. Scott Def is gifting 5-tier sub to the Tsoding community. Thank you so much for 5-tier subs. And Fluffy Poga, Darren Dells, UT61A, Zombie Foo, and Lil Biomac, welcome to Epic Virtual Machine Club. How about that? And to celebrate this epic sub gift, I think I'm gonna go and make a little bit of a TSMR. Are you guys ready? Are you guys ready for a little bit of a TSMR? Here's your TSMR. Coffee. It's actually not coffee. It's actually tea. I think I overstepped it a little bit. I didn't actually plan to. I just got distracted by explaining the plan for today. So is the KG vodka dead? Is the KG vodka dead? I suppose KG vodka is dead. Let's actually try to fix it. So I'm gonna SSH to my VPS, and then I'm gonna just restart the KG vodka. Oh yeah, SSL connection got dropped or something. Try to ping it now. It should be working now. Yikes! Yikes! One more time. Developing bots is a pain in the arse. Nope. I think I know what happened. I think the login has expired. I think that's what happened. Yeah, so the login information has expired. I'm gonna fix the KG vodka a little bit later. So you know the classical situation. You need to generate a new token and shit like that. So yeah, I'm not gonna do it right now because it's just too much effort and I can accidentally expose some sensitive information, so I don't want to do it right now. So yeah, let's continue just developing, and tomorrow the bot should be fine. Hopefully, we'll see. So we're gonna start with improving our assembly language. Specifically, I wanted to add two things to our assembly language. It's the comments and the labels. So right now we do have an ability to jump. In our language, but you have to actually provide the specific absolute number of an instruction to jump to, right? So, and they are numbered from 0, right? And usually editors number them from 1, which makes it super inconvenient to locate where exactly you have to jump. So it's like a huge pain in the ass, right? And on top of that, we ignore empty lines, which makes it even more confusing and more difficult to specify the address where to jump. So we want to have an ability to have loops, right? So you don't have to do this kind of shit anymore. So I think something like that would be interesting to implement, would be really convenient to implement, and shouldn't be that difficult to implement. So, but we're gonna start with the comments. And what character we're gonna use for the comments. Usually in assemblies, as far as I know, we use semicolon, right? But it's kind of like a very old style of assembly, so maybe we should use like hashes. Music's too loud. I don't know, like according to my volume levels, the music is actually okay. So I don't know what you guys talking about. I think you're debating me. So like I'm looking at OBS right now and my voice is actually higher than music. Except for gas, which uses hash. Okay, so alright. Yeah, I'm telling you, people are debating me. So we're gonna use hash, I think. I kind of like hash, and it's kind of like a modern way of denoting one-line comments. So we're gonna go with that. So let me start my Emacs from within the development environment. Maybe dash, yes, sure. Maybe we're gonna also develop Emacs mode for Bosom. To be fair, I don't really wanna call it Bosom, because it's sort of like, it's to indicate that it's related to eBisp, but I want to kind of decouple the virtual machine from the eBisp itself, so you can use virtual machine without eBisp, but in the future eBisp is going to use it. So I would like to call it maybe just Bosom, and then later we're going to have a disassembly which is going to be called debosom, which makes more sense, I think. So I'm going to start with renaming everything. We're gonna start with renaming everything. This is gonna be just BMI, which is like a virtual machine interpreter, right? Virtual machine interpreter. Maybe it has to be also called BME because it's not really interpreter, it's emulator. It's an emulator. Body mass index, yes, that's what it is. All right, so let's go. So we're gonna shave a little bit of yuck by renaming things. Even right now, machine has nothing to do with eBisp. Yeah. But in the future, we're gonna, use eBisp is gonna use EBM. All right. So let's rename this to just Bosom. I'm trying to open this file. For some reason, it was really difficult to open it. And I'm gonna query replace eBosom with Bosom. There we go. And on top of that, I think I need to go to the examples and query replace eBosom with Bosom. There we go. So, and this is how I essentially renamed two files using query replace in Emacs. That's the beauty of the file manager in Emacs. It's actually super convenient. So, and somewhere in Make, I have to do a similar thing. Yeah, these are all the places where I have to actually do all of that. And let's see if all of that compiles. I'm gonna do -b. It seems to be compiling, and then I'm gonna try to compile examples. Examples do compile, and then I can do BMI examples Fibonacci. So it's gonna be BM, and here you go. Everything is interpreted correctly, or rather emulated. So I'm gonna go to here and replace this thing. To be fair, it would be nice to do something like eBosom, just grep for eBosom. Okay, I think everything's okay now. So this is basically all of the replacements that we managed to do. All of the replacements, nothing special so far. Introduce BM executable. We also have a bunch of to-dos. Yeah. Nice. So eBosom rename to Bosom. Cool. Do we need to actually document that? Do we need to actually document that? We can. Something like components, right? Bosom. Assembly language for the virtual machine. For examples, C. Examples folder, something like that. Cool. What the fuck is a virtual machine? It's a good question. It's a machine that is not real, but what is a real machine? Right. How do you distinguish? Oh, you know, in the version. That's what you mean. I see. All right. Document Bosom component of BM. It's actually not really like a component. It's like a tool in a tool set, right? So there is like a tool set, tool chain, or like a BM tool chain, and it consists of Bosom, BME, and debosom. Yeah, we'll definitely need to implement debosom that disassembles everything. Virtual machine. Well, how do you even like read the second word? Bachin, because like Bach or Bachayne. I don't know. An important question: do I need to have a birch to run virtual machine? Yes, you do need to run a birch. To have a birch to run a virtual machine. Holy fuck. Okay, my brain cannot keep up. So let's actually push everything. So we renamed eBosom to just Bosom, and I think it just looks better. So we have Bosom BME, and yeah, Cool. So another renaming that I would like to have is to rename BMI to BME, because it's not really interpreter, okay? It's an emulator. That's very important. It's an emulator. So I want to say that thank you. You're the proof that Twitch can also have good quality and not only naked Twitch. Why we don't approve of that word. It's a Monka2OS word. We don't approve of that. But I'm really glad that you like my stream. All right. So let us see. So let's rename BMI to BME. Let's replace BMI, BME. There we go. Do we need to do anything else? I think in the git ignore I also need to do the same thing. Somewhere here, let's say BME. Yeah. Haha. BMI. Okay, and in the readme we have that. All right. And we're gonna have something like this. BM emulator. BM emulator. Used to run programs generated by Bosom, right? And we can try to do something like this. I think this is how we can like point to a specific section, right? Because for each individual section, I think GitHub generates like a thing to which you can like click, and it actually creates an anchor. And yeah. Oh. I'm already getting banned for bad words or something. Welcome back, by the way. Welcome back. Refresh your page, by the way. Refresh your page, otherwise you're gonna have like a huge delay. I liked the channel so much and happy. I think they were trying to debate me into saying this word. I think that's what happened. That's why they didn't follow or anything. I don't think they're being genuine. Alright, so let's continue. So used to run programs generated by Bosom. Okay, so daily test has been passed. Let me see, BME. BMI. So I think I replaced all of these things here, so it should be all right. Okay, looks good. So, and now I'm ready to rename this entire thing. So BMI to BME. And I'm going to push that right into the repo, So before we go into the issues, I really want to implement the disassembly. I think it's going to be cool to have some sort of a disassembly. What do you guys think? Just to inspect the binary files and shit. Yeah, I kind of like this idea. So we're going to have Bosom, BME, and we're going to have dbosom, right? But first I need to create like a dbosom.c file. So first I need to include the virtual machine.h, and it's not going to work unless I also define BM implementation. Here's the BM implementation, and there you go. So what we're going to do here, what kind of arguments we're going to accept for disassembly? We're gonna have a debugger for Bosom. It's actually a pretty good idea. So we need some sort of a debugger. Okay, so let's create separate issues. Wait a second. Disassembly is actually with I, not with E. Yeah, you have to like a disassembly. Disassembly. Yeah, I'm an idiot. So it should be actually called something. Yeah. Huh. DASM or BDSM BASM. Okay, so we need to come up with a better name. It should be something like, I suppose, let's remove that. It's gonna be DBASM. Yeah. So BASM, DBASM. And we also need to implement the debugger as well. DSBASM or DEBASM? I'm just not sure if debasm is okay. Yeah, D means undo. Maybe it's okay then. Maybe it's okay. Okay, so let's actually do debasm. I kind of like how the word looks like. To be fair, like debasm. Alright, so what we're gonna accept, so in terms of a usage, right, in terms of a usage, I think we're gonna accept only a single file, right, only a single file, so it's gonna be debasm input bm, and it's gonna print the assembly to the standard output. I think that's gonna be the idea. So this is the usage, right, this is gonna be the usage. Okay, so if args is less than 2, that means we don't have enough arguments to actually facilitate the disassembly, and we're gonna print an error. std error, no input is provided. And then we're gonna remove return 1. So okay, how are we gonna go about that? So we have one function in the virtual machine, load program from file. Okay, so you need a virtual machine, and you can load a program from file, and the next thing we can do is iterate through each individual instruction of the program in the virtual machine, and print its representation, its textual representation. Should be actually pretty straightforward in my opinion. So let me see how we can do that. First we need to allocate the virtual machine on the static memory, and then load. Oh, it's kind of interesting. So all of these functions like load program from memory, load program from file, they accept the virtual machine, but for some reason for this function I decided to accept the array of instructions, which kind of breaks, you know, the consistency, right? All of these functions, they work directly with virtual machine, and I think I implemented it at the time where program was not a part of the virtual machine. That's why I did it this way. So I think one of the things I want to do before I'm going to continue, I'm going to actually refactor it and accept virtual machine. So what's funny is that it doesn't need to modify the virtual machine, so we're gonna make it const, right? So because we need to only save this entire thing. So designated initializes for arrays. Yeah, they're pretty cool. I do agree with that. Okay, so we have discrepancy between declaration and definition. So let's actually fix that. Let's try to fix that. And what essentially we're doing here, so instead of accepting the program, we're gonna accept something like this, right? So we're basically just, you know, doing it like this. Yeah. The assembly can use the same approach as execute. In fact, it has to decode the inst. You think I don't know how to implement this assembly? Thank you so much, Katul. All right, so let's continue. Like I'm telling you, every time you say something to me, you're literally trolling me. So I'm starting to think like I should just ignore every your message. Like, why are you telling me these things? Like, I think you're intentionally just trying to piss me off. That's what you're trying to do. Okay, so saving the program, and I'm gonna just remove all of that, and I'm gonna put it like this. What's up, old NaN? Welcome to the stream. Welcome. All right. So let's continue. And this has to be a pointer, by the way. It has to be a pointer. Cool. So assembly. All right, I refactored it. So, and let's just commit that. So I'm not gonna commit debasm yet. And what we're gonna do. Make this function accept BM instead of the program, instead of the not the program. And I'm gonna push that right into the repo. Okay, so we refactored things a little bit. And now we can continue to continue to implement the disassembly itself, right? So I'm gonna iterate through each individual instruction, and for this thing, so it's gonna be BM program size, right? And we need a way to convert an instruction to a string, but to be fair, it has to be like this dynamic string. So let me try to do a switch. So we're gonna do BM program I, and we're gonna take a look at the type. So oh, okay, so we also need to add the disassembly to the build. So let me see what we can do here. So it's gonna be debusm, right? SRC debusm C, and it also depends on bm.h. So let's copy paste this thing here. I need to go here like this. Debusm, and it's gonna be debusm. Okay, so now we're not building because debusm is not part of all of the executables. Oh, this doesn't have to be a pointer. Yeah, I keep forgetting about that. There we go. I finally, like, I was trying to trigger the error for this particular thing. I was trying to trigger an error. Okay, so this thing is interesting because this is a word. This is a word, and yeah, we're not handling any of the type of these instructions. Yeah, for each individual type of the instruction, we have to implement a printer, right? We need to implement the printer. Okay, so let's actually go to the BM implementation, right? And take all of these instructions here. And actually put them here and just dispatch upon them. And for each of them, we're gonna just implement the printer. So case, and I'm gonna go like that. Query replace this with this, like this, and I think, do I need break? I think I do need break, so I'm gonna do it like this, break. Cool. So now we have all of these instructions. So what we're going to do here, as already mentioned, for each individual instruction, we're going to print on the standard output, and it's your responsibility to actually redirect it somewhere. And 25 lines of code in 10 seconds. I mean, it's not that hard. You can just copy paste the code. Look. So 32 lines. Another 32 lines in 1 second. All right. So let me see. I'm gonna do print f, and in case of a nope, guess what we're gonna print? We're gonna print nope. Epic disassembly, isn't it? I think it's pretty epic. For the push. Okay, push is a little bit interesting because it has an operand, right? It has an operand. So in case of an operand, we'll have to take BM program I operand. There we go. So there we go, we have a push. In case of dupe is kind of like similar, right? But it also takes an operand. Minus, okay, this one is interesting actually. We have a lot of duplication. Should I care about duplication right now? Should I care about it? I'm not quite sure if I should care about it. So maybe I'm gonna just keep duplicating code, right? Until I cannot bear it anymore. And then I'm gonna get rid of the duplication. So the plus is gonna be that. For the minus, we're gonna have that. Right, so here's the minus, here is the multiplication, here is the division, and jump has an operand. Yes, it does have an operand because it has an address, the number of the instructions to which you have to jump. Right, so, and it's gonna be something like this, operand. There we go. So we also have jump if, right, which is conditional jump, and I think this is how we're gonna go about that. So then we're gonna have equality, right? Equality doesn't take any arguments, any operands, because it operates on the stack, right? So it takes them from the stack. Halt doesn't take anything, and print debug just prints a single value on the stack. So there you go, we implemented the disassembly. Isn't that epic? Isn't that epic? I think it's quite epic. Mein Gott. Mein Gott. Oh, by the way, and I forgot a very important thing, I forgot to even load the program. So it's kind of interesting. I'm just taking a like empty virtual machine, right? Taking an empty virtual machine, and I'm just iterating over an empty program, but I need to first load this thing, right? So const char input file path. Is the sound okay, by the way? I hope sound is okay. So bm.h, so bm load program from file. This is the thing I need here. So this one is going to be RGV1. So we're going to provide the virtual machine and the input file path. And there we go, we loaded a program into our virtual machine. We're iterating through each individual instruction, and for each individual instruction, according to its type, we are printing corresponding lines of bosom. Yes, so it's assembly for virtual machine. Alright, so let's try to compile that and see how miserably this shit will fail. It fails quite miserably. I think I have to use LD instead. Okay. So it's gonna be LD, there we go. We're gonna put that shit everywhere, and there we go. There we go. Isn't that epic? So let's take a look. Here's the bottom. You didn't provide any input. So do we have any binaries? So let's take a look at the examples. Right, let's take a look at the examples. So here are the examples, and we do have some binaries. Let's take a look at 123 BM, right? If you take a look at 123 BM, this is how it looks like. It's a binary file. It's completely unreadable by human beings. But if you apply debusm to it, you will get the ASM instructions. So you can clearly see that it's just push 1, push 2, push 3, plus, and it just sums up 1 to 3. So yeah, it works quite well. We can take a look at Fibonacci example. So if you take a look at Fibonacci example, as you can see, it's yet another binary file. It's completely unreadable. But if we disassemble it, debusm, there you go. So we push 0, 1 to the stack. Then we duplicate previous element on the stack, duplicating these two elements, and then we sum them up, creating the next Fibonacci number, and then we jump to the second instruction, and they're numbered from 0. So this is going to be zeros, first, second, third, fourth, and so on and so forth. So you jump to the instruction 2, and you basically loop over and over again, right? Generating Fibonacci numbers. That's basically what's happening, right? Generating Fibonacci numbers. Yeah, it actually matches the assembly file from which it was generated. So if you take a look at the fib bosom, that's what it is, right? But it's indented, right? So it's indented, so it looks a little bit better, but our disassembly actually generated everything correctly. So yeah, there we go. That's how easily we can implement a disassembly for our bytecode. So it's going to be debusm. And I think it makes sense to maybe document all of that. Debusm. Disassembler for the binary files generated by bosom. And we're gonna redirect back. Rex, byte, and mod or mbyte. I'm not sure what that means, I'm sorry. Alright, so let's do a committee. implement debusm, and we're going to push that right into the repo. So, and by the way, all of the source code can be found here on the GitHub if you're interested. Oh, it's x86-64 encoding nonsense. Okay, I never actually worked with x86-64 encoding, and to be fair, I kind of don't want to use LLVM when I'm going to be implementing JIT compilation. And yes, this thing is going to be JITed in the future. Or maybe I haven't decided whether it's going to be JIT or is it going to be AOT, because I think AOT makes a little bit more sense. Like you load the bytecode into the memory and then you just translate it to x86-64 and then execute it. We'll see. Would the ED editor for the VM be called... Yes. Thank you, Duck of Doom 12, for 27 months of Tier 1 subscription. Thank you, thank you, thank you, and welcome to our epic AOT club. That's right. Alright. So I think I already pushed everything. What I want you to do, I want you to take a look at how the README looks like. So does it redirect? So, okay, it's supposed to be redirecting. I think it is redirecting. Okay, cool. So I wasn't sure if this link will work. It does redirect to here. And if I click on examples, it actually goes into the examples. And unfortunately, GitHub does not support BASM syntax. We're not popular enough. We're not popular enough, unfortunately. Alrighty. So, is there any to-dos I want you to address? Yeah, I want you to introduce BM execute program. Right. So instead of like executing this entire stuff manually, I think we need to have BM execute. Make a petition to GitHub. I think you just need to contribute to their repo of syntaxes or something like that. Hello, is your VM is for not implement compilation to ELF on Linux, for example? I just started watching this project today. And I just started this project yesterday. And I have no idea what you're talking about. It doesn't really have much, so... BM emulator, are you planning to design your own CPU for BM? Maybe, we'll see, why not? It's actually a pretty simple machine if you take a look at the definition of the machine. Let me see. So it has a stack, right, where it puts the words. It has a separate area for the program, and yeah, and it has a single flag halt. That's it. I'm pretty sure you can design like a... If we simplify the representation of the instruction, maybe we can design like an actual hardware that can execute that. Who knows? GitHub to recognize BASM files as assembly. Cool. So yeah, but BASM is not as, you know, stabilized yet, so it's probably going to change in the future. So I order a bunch of ICs from China and solder it together next week. Well, I mean, I haven't finished designing this thing. Like, why everyone acting like I've been working on this project for a year? I literally started it yesterday, guys. Calm down. Like, I'm not that much of a god coder. Like, I know that it's 528 lines, but I literally started to do this yesterday. It doesn't have much. Calm down, we're slowly designing this thing, okay? We're gonna implement everything, we're gonna have everything eventually, okay? So yes, we can already generate Fibonacci sequence number. I can even show you, right? If you have this example fib BASM, right? So this is the program. You can easily do BASM fib BM, and it generates like the binary file for you, which later you can evaluate, right? And it actually generates you Fibonacci numbers. Yes, I know it's cool, but it's not finished yet, okay? I started this thing yesterday. All right, so let's continue. Is Apple M2 going to implement BM instruction yet? I don't want to have anything to do with Apple, I'm sorry. Do we buzz them every day and drop everything else? I don't understand this question. Okay, so let's actually go ahead and implement the thing I want you to implement. I want you to introduce the BM execute program that executes the program for you instead of you organizing this lame loop yourself. That's basically what I want you to do. All right, so let's go ahead and do that. So we have a BM execute instruction, and yeah, so you have execute a single instruction, so it's a single step in the machine, or you can just keep executing program. So I think it would also make sense to accept some sort of a limit, right, for how many iterations you want to do all of that, so we can accept you know, int limit, and if it's going to be negative, it's not going to have any limit, so it's going to be unlimited. All right, so let's go a BM execute instruction. So here's the single instruction, and what we need to do here, I think I'm going to put it here somewhere, maybe. I already lost the thing I wanted to do. It's kind of interesting. Execute program. Yeah. Let's go back. Okay. So, what we're doing. So we're going to start with the following loop. BM halt. Right. While virtual machine is not halted, right, we execute a single instruction of it, right? We execute a single instruction of it. And if instruction is OKEG, well, in fact, if it's not OKEG, we're supposed to return that instruction immediately. We're supposed to return it immediately. And I guess that is it. And then if everything went okay, we're gonna just return error okay. So that means no errors were generating while executing the program that you have in the memory of the virtual machine. No, someone is gonna implement the Java compiler for BM. I mean, nobody's gonna do anything for BM. It's not gonna be a thing. So it's like a small pet project that I'm developing for myself. Don't expect this to become something big, right? So, like, seriously, like, it's not a thing. Let's just like enjoy the moment of recreational programming and just make a virtual machine without thinking, you know, about like compatibilities or, you know, future of the project. Let's just implement a virtual machine. Like, why do we have to think about all of these stupid things? Come on. So we're executing the program, and then I'm gonna go to the emulator. So where is my emulator? And yeah, so what essentially I'm doing here is I'm executing the program, pointer to the VM, and the limit is going to be 69 as far as I know. Oh yeah, excuse me, just a second. I want to say thank you for your Haskell explainer. YouTube helped me ton. Here is a coffee. Enjoy. Thank you. Thank you, clearly not to go. I don't really drink coffee anymore, but I do enjoy a cup of a good Earl Grey. Thank you so much. And I'm really glad that they helped you. So yeah. Okay, cool. So after we executed the program, the thing I want to do, oh yeah, I need to actually, yeah, first I dump in the stack. So after executing everything, I'm just dumping the stack, and I want to check the error. If error not equal error okay, we're gonna say f print f error. and we're gonna print it like so, error as sister, and there we go, and we're gonna actually return 1 instead of 0, indicating that something went wrong. All right, so let's try to recompile all of that, and something, okay, so we have a situation that we don't use limit. So the question is, how are we gonna use limit? So how are we gonna use limit? So obviously, if limit was always set, we could do something like this, right? Less than limit, like this. But to be fair, we don't really need to do I, if you think about it, right? We don't need to do I. We can do something like limit is greater than 0 and just decrement the limit, right? Limit. While greater than 0. And this one is very interesting. We could do something like this, greater than 0 or limit is less than 0. Which is essentially limit not equal 0. Right. So, and because of that, if limit is positive, it's gonna execute a limited amount of times. If it's negative, it's gonna execute unlimited amount of times, unless limit wraps around. So maybe we can actually put a condition for a limit. If limit is greater than 0, only then we're gonna subtract it. And that turns back to a while. Right, so here's what we have. While limit not equals 0 and the virtual machine is not halted, we keep executing it. If limit is greater than 0, we decrementing it. Does it make sense? So this way, if limit is positive, it's gonna execute limited amount of instructions, and if it's negative, it's gonna execute unlimitedly. Right, so this makes sense? I think it makes sense. I think it's kind of cool. Is there any performance difference between limit minus minus and minus minus limit? In 2020, no. In 2020, no. If some old-ass professor in your uni tells you that there is performance difference, well, tell them, okay, boomer. Because in 2020, it doesn't have any difference. I'm not even joking. Seriously. What is the halt is in the middle and there is more inst to execute? What is the halt is in the middle and there is more? What if? How to answer that? I mean, well, you fucked up, I guess. If you have a halt in the middle and you have more instruction to execute, congratulations, you fucked up by putting halt in the middle. What else I have to say? Like, so it's like, what if I have like this code, like a lot of lines down below, and I put exit here? Well, I fucked up. I mean, like, why did I put exit here? Like, it's... Is that what you're asking? Too bad, I guess. Like, why do you asking these questions? I don't understand. Okay, so we also have to provide std error. Alrighty, so we have that shite. And I'm gonna do BME, and I'm gonna just execute fib BM, and there we go. So it's executed and generated a bunch of fib instructions for me. So what's funny is that if in BME I put -1, it will execute indefinitely, so it's never gonna actually finish. Oh shit. Oh, I see. Okay, that's actually cool. So it's not gonna execute indefinitely. It actually overflows the stack because it actually grows, I see. But, and this is probably one of the reasons why I didn't implement like automatically growing stack, right? Because look what's gonna happen. Yeah, it's actually overflowed the stack, and our error system actually caught that. What size is that? I think it's like, I don't remember, I think 69 or something? I don't remember, it doesn't matter. You can actually change it at any point. Yeah, and we don't need execution limit anymore. So here's BM stack capacity, program capacity, and so on and so forth. Yeah, so the size of the stack is 1024, and the size of the program is also 1024. Let me guess. But Zosin, what if I have a bigger program? What do I do? So the answer is the project is not finished yet. So that's the answer. All right. Let's make a cup of tea. Does anyone have any questions, by the way, while I'm making a cup of tea? Jiang! Oh my god, Jiang, welcome! How are you doing? Really glad to see you. Welcome, welcome, welcome. I'm gonna make a cup of tea. How about that? That's what I'm do. That's what I do today. Does anyone have any questions about virtual machine or what we're doing or what kind of tea? What tea do you drink? I'm drinking Earl Grey today. So yeah, I'm actually running out of Earl Grey yet again, so I'll have to probably go do groceries and buy more Earl Grey. I have, but nothing related to what you're doing. That's actually scary. Add support for XSS emulator option. I don't know what it is. It sounds like some sort of a JVM thingy. Do you drink other teas as well? Yes, when I ran out of Earl Grey, I do drink other teas as well. Java stack size. Maybe we're gonna actually make these kind of things parameterizable. Why not? When are you going to have Jiang design PCB for BM-based Raspberry Pi? I don't know. First of all, when I finish the design, and second of all, if the Jiang will be interested in this kind of stuff. I mean, Jiang has probably more interesting and important things to do than trying to design a PCB for this virtual machine. Don't really want to waste his time. So yeah. Alright. So I'm gonna go to the kitchen and I'm gonna turn on the kettle. Could probably just use an FPGA when you just need to write a VHDL. Yeah, probably. Yeah, to be fair, like, it would be better to just use FPGA for this machine. It's just... Wait a second, chat. We had the plans for FPGA stream. Are you thinking what I'm thinking? You know, when the virtual machine design is ready, we can, you know, try to make a hardware like that actually emulates that machine. I never actually did any FPGA shit, but it sounds like it's an interesting idea, but we need to finish the design of virtual machine first. And we'll see. On top of that, this virtual machine is actually dynamic. And I do plan to use shit like NaN Boxing and stuff. I'm not sure to what extent I will be able to implement like a FPGA for this thing. It's gonna be it's kind of difficult. But anyway, so I'm gonna go to the kitchen, I'm gonna turn on the kettle, boil out some water, and I'm gonna go back. Don't go anywhere or I'm gonna overflow your stack. And as you can see, I'm quite good at it. Look at this log. I'm quite good at overflowing stacks. Coming. I came. What's up? What's up, Epic Gamers? How's it going? Alright. So we're waiting for the water to boil up. And let's extend our bosom. So essentially, I want to add some flags for the bosom executable, so I can provide input, output, and the limit, execution limit. Do you have any additional instructions in mind you may want to add VM in the future? Probably. Alright, so let's actually start parsing command line executables. Command line arguments. Holy shit. Command line arguments. So I'm gonna implement the shift thing. So I'm gonna accept this thing by a pointer. So maybe I'm gonna even do it like that. And triple star developer, by the way. Isn't that epic? Isn't that epic? I think it's quite epic. Samurai Goo, welcome to the stream. So we're gonna assert a certain thing, I suppose. Right. So, by the way, for this one to know, this is a pretty useful operation that I use all the time. So essentially, what it does, it lets me do the following thing: shift arg or argc, argv, and sort of pop out the next argument. Right. Sort of pop out the next argument. For example, input. Hello, Zombichu, welcome to the stream. But you can do 4-star. Well, I never had an opportunity to do 4-star development. I cannot imagine how it's gonna look like, but... And the only 3-star development I've done is this one, where I had to pass argv by a pointer in C, so... Yeah, and so basically what it does, it acts like a shift in Perl, right? It just shifts the argument and it makes it like easier to parse things, because you can just, you know, pick to the next argument quite easily. So I kind of like this operation. I kind of like it. Not gonna lie. I had to be a 4-star the other day. Nice. Was it difficult? Was it necessary, by the way? That was scary. Well, I can't imagine. So essentially what you need to do, you need to perform like 4 indirectional jumps, right? You have an address of an address of an address of an address, and yeah, could be difficult to comprehend. Alright, so what we're expecting here is argc to be greater than 0, right? So that's what we expect. And an array behind that. Oh, I see. So you'll have to like go through the maze of indirection, then find that array and then iterate it. Goddamn. Alright. So what we're doing essentially here, we're gonna have something like a result, right? And it's gonna be argv. So here is the result, and then we do argv +1 and argc -1, and then we return the result. And there you go. That's how we implement that. It's actually a pretty simple operation. It's pretty simple operation. So, and first, before trying to handle everything, what I want to do, I want to skip the program name, right? Because the first argument usually in C a program name. Skip program name. We don't care about it. But we might as well actually. Yeah, let's actually maybe use it. Something like char program. Right. So that then we can use it in here. Who knows? Right, maybe we can use it in here. I've only worked with M4. Oh, somebody actually worked with M4. Interesting. I also worked with M4 when I was a student, a really long time ago. Yeah, I almost forgot everything. Okay, so I think my kettle is ready, so I'm gonna go to the kitchen, brew up some tea. Don't go anywhere, or, as you know, burn band. What? All right. So let's continue. Let's continue. Just staying here, listening to music while he's getting Tito with the band. Good. Okay, good. So what's gonna be the next thing? If argc equals 0, well, input is not provided, right? So this is basically what we can do. Error expected input. So, and then we can have something like this, where we can do it like this. Shift, argc, argv. Similarly, yet again, if we experience this thing, expected output, and here's the output. argc, argv. Cool. So, but maybe we want to extract this repeating code to something like usage, right? So we're going to have usage, we're going to accept string, and we're also going to accept program, right? So I also going to put it like that. So a boom, 7, and I'm going to put it here. And this one is going to be string. Cool. Usage, std error, program. Cool. Boom. There we go. Isn't that beautiful? Look at that. Look at that. So this is how we parse command line arguments, right? So we take the program that we're going to use for usage and stuff like that. Then we check if there's input. If there's no input, we report that, and so on and so forth. And that's quite convenient. If we try to compile this entire stuff, it does in fact compile. And if I try to, what program we're doing? It's Bosom, right? It's Bosom, and it says there's no imp. Classic. Classic. So I guess I just have to remove this thing from here, right? And yeah, there we go. Usage, if you do provide the input, it will now complain expected output and still have usage. And then if we provide the output, could not read file, no such file or directory. As you can see, it checks everything. Checks everything. Beautiful. Absolutely beautiful. My God. But that's not enough. Right, because now we also need to provide the limit, the execution limit, right? Because interesting. I needed to do that not for the Bosom but for BME. I mean. I was actually implementing the argument for a wrong executable. I have too many executable, okay? So I have 3 executables, right? So I have emulator, assembler, and disassembler. Well, I mean, it's not like I'm gonna throw away these changes, okay, chat? It's not like I'm gonna throw away. These are useful changes. I actually wanted to refactor each executable like this, but and I'm gonna probably commit that, but I just realized that I was doing the thing for a wrong executable. That's why I'm unemployed. Anyways. So, okay. Let's drink some tea. Software development is hard, okay? Software development is hard. Usually, like in a project, you have 1 executable and you don't have to worry about it, but it's 3 executable. You see, the shit starts to get really complicated, and sometimes that's what happens. Cheers! Perfect timing with the music. 2021 and 2020. Exactly, Lindra brother. All right. So essentially, we're gonna have like flags and shit. So I need to do like the same thing, but for emulator, not the assembly. Right, assembly doesn't really need any of this stuff. Okay, so I have a bunch of stuff that I would like to commit as well here. Okay, let's double check that everything compiles. There we go. So here's the changes that are completely unnecessary, but I did them anyway, but they are not useless, so I'm gonna commit them anyway. So it's gonna be refactor CLI parsing in bosom, even though it was completely unnecessary. Right, so though it was completely unnecessary, well, I mean, we did it, so whatever. Have you listened to the new Attack on Titan opening? No, I haven't. I'll listen to it after the stream. I haven't watched the first one, or the second, I don't even know how many seasons, I haven't watched any of Attack on Titans. Alright, so now. Okay, I'm gonna pretend that I never see that. So, what we're gonna have here, we're gonna have an input like this, so we provide an input, and we're also gonna have an optional limit, right? Limit, execution limit, and we'll need to parse all of these things. 4 seasons, okay. So the new one is the 4th one, if I understand correctly. Oh, AOT, Attack on Titan. Now I understand why people were saying that AOT is better than JIT. Attack on Titan is definitely better than just-in-time compilation, that's for sure. Okay, so I kind of want to copy-paste this shift operation to this executable, but again, I'm falling into the trap of repeating this operation over and over again, and yeah. Is your C main programming language? No, C is not my main programming language. I don't have a main programming language, whatever is that supposed to mean. Chat, wait, what is JIT in this AOT context? I don't think it has anything, it doesn't have any meaning in the context of Attack on Titan, it was just a stupid pun. Alright, so I kind of want to move shift inside of BM, but it has really nothing to do with BM. So, advent of Zotic. It's when I go on a break for 25 days and everyone is waiting for me, so this is advent of Zotic. Anyway, whatever. So, this is what we need to do here. So it's going to be usage, stream, program, and this is what we're gonna do here. std with some utils files. I'm not a big fan of the utils files, to be fair. By main programming language, I mean the one that I use the most. I don't know which one I use the most, to be fair. I used a lot of languages simultaneously. Have you seen my Advent of Code repo? I did this Advent of Code challenge where I used different language for each individual day. I used 25 different languages. And to be fair, I don't know which is my, the concept, in my opinion, the concept of a main language is not really applicable to me anymore. Yeah. Speaking of util files, I'm a big fan of cohesion in programming. I know that this notion is actually like long time forgotten in cohesion in computer science, but I still kind of like to follow it. Okay, so in computer programming, cohesion refers to a degree to which the elements inside a module belong together, right? So we have this notion to what degree like particular functions belong to together to modules, and there are different like degrees of cohesion, right? Different degrees of cohesion. Coincidental cohesion, the worst kind of cohesion, also known as utility classes. The parts of a module are grouped arbitrarily. The only relationship between the parts is that they have been grouped together. That's it. So, and you want to kind of strive to like a better level of cohesion. And that's why I don't like utility classes. But maybe I'm, you know, being stubborn for no reason whatsoever. Maybe it doesn't matter. So, yeah. Absolute cohesion, if everything in one file. Yeah. Cohesion is something I've been trying to do, but now I have a name for it. Yeah, and what's interesting is that it's a very old notion that people came up with in 60s. Fucking 60s. People knew about this concept for 60 years. Just think about it. It's just like it was long time forgotten. Nobody just uses that notion anymore, and nobody teaches about that notion anymore, but people knew about it very long time ago. 60s. But everyone knows about coupling, yeah. They usually like kind of go together. Alright, so here's the usage, and that's exactly what I want to do. I also want to like provide the program as usual. So here's the expected input and so on and so forth. Oh, okay, so this is how we're gonna do all of that. I'm gonna extract the program first, so it's gonna be a shift and a program, right? And while argc is greater than 0, that's what we're doing. And const char flag shift argv, and here's where we're gonna try to understand all of that. If flag, it has to be strcmp flag, we have -i flag. Another one is strcmp flag using Zozin. I just actually merged together words Zozin and using. Zozin, why don't you use switches? Doesn't C have switches? Alright, anyway. I need more tea, by the way. Zozin, use switches. Why are you not using switches? Okay. So the next thing is going to be the following. If argc equal to 0, we're going to throw an error saying that, first of all, we're going to print the usage, right? It's going to be usage program, std error, right? This is definitely going to be std error. And this is going to be std error. No argument is provided for flag right? And then we're gonna exit with 1. So this is how we handle all that. But if an argument was provided, so that argument is gonna be so input. Do we already have input file path? Okay, so input file path initially is going to be null. There must be a better way to parse args than this. New to this channel? New to this channel? I see. Welcome. Okay, so it has to be something like this. Every time I'm trying to parse argument in C, like third of the like chat starts crying. Because they probably never seen C. That's my only assumption why they start crying and screaming like little babies. Alright, so no argument is provided for this flag. And this is how we parse this thing. Okay, this is how we parse this thing. And also we're gonna have a limit here, right? So this is gonna be a limit. It's gonna be -1 initially, right? It's gonna be -1. So then we have that, and I need to take a look at A to I, right? A to I. So in case of you can't parse A to I, converts the initial portion of the string pointed by to integer. The behavior is the same as Return value, converted value. So maybe this is what I need to take a look. str to L. Alright, and what does it return in case of an error? Returns the result of the conversion unless the value would underflow or overflow. If underflow occurs, returns long minimum. Okay, so what I'm thinking is that maybe we can simply do the following thing. Limit shift argc argv a to I. So essentially, if you never provided that, we're never gonna execute that, so it doesn't really matter. Okay, and then we can use usage program. Come on. fprintf std error unknown flag as flag, and we're gonna exit. There we go. That's it. That's the whole parsing, by the way. I don't know why you keep crying about it. It's actually pretty straightforward, and it's actually pretty simple. So another thing that we need to check after we're done parsing is whether we do have input file path, right? So if we don't have an input file path, we have to say that you forgot to provide the input file. So, and we can just copy paste this part, right? Usage, error, input was not provided. So we can actually do something like this. There we go. So, and another thing that I would like to probably do is to prefix everything with error. Is null and the same thing? No, they're not. They're actually not. Null is a null pointer. Empty string is a pointer that points at a memory that doesn't have anything. So you can even probably check something like null equals that and confirm that they're like, it's false. It's different things. Bugs, whatever, get opt3 has. Nice. Okay, so input was not provided, we print this thing, and then here we just use input file path, and everyone is happy, and here we can just use the limit, right? Here we can just use the limit. There we go, there we go. Okay, so there we go. So I parse the command line arguments, and now our emulator has the limit. Oh, I forgot to do this thing, right? Error. I didn't finish prefixing all of the errors, so I need to do that. Doesn't compile because it's input was not provided. Yeah, there we go. Everything compiles. Cool, cool, cool. We can also probably wrap all of that into some sort of like macro. Some sort of a macro, but I'm not sure if I'm gonna do that. So let's see if it's gonna work or not. So if I try to do BME on examples fib BM, right, and I have to do it like that, by the way, so it's gonna overflow. So what you have to do, you have to limit your execution to a particular size, 69. As you can see, you can limit it, right? You can do 10 instructions or 20 instructions or 69 instructions. In case of 69, it will give you this amount of these things. But if you don't limit your execution, it will never finish, and at some point it's going to break everything and it's going to Stack Overflow, and yeah, there you go. So this is exactly what I was working on. I was working on parsing these command line arguments, and of course, if you execute it like that, it will tell you that how to use this thing. Thank you, NaN. It's a very old one. It's a very old one. I actually need to buy more of these things. I actually have only 2 of them that are not as ugly. Alright, so let's see. I want to add another flag here. You know, the help flag. So essentially, if you're gonna encounter the help flag, it's gonna quit the execution. and just show you the help. Something like this. I think I'm doing a REPL for the bytecode as well. Not really. Not really. I don't think it's really needed. But maybe. We'll see. So if we encounter help, the only thing we do here is just std out, usage std out for the particular program, right? And that just exit with 0. Just exit with 0. Cool. Did I add that to usage? There we go. Cool. If I do -h, it doesn't throw any errors, and it just shows you the help. If you do something like that, it will throw an error. Cool. If you provide the limit, it still expects an input. Cool. Yeah, we actually have plans for the debugger. We have plans for the debugger where you can step debug and stuff like that. We're gonna implement that eventually. We're definitely gonna implement that eventually. All right. So what did I do here? I actually fixed introduce BM execute program. Yeah. Introduce BM execute program. And clean up CLI parsing for BME. Oh, everything actually fit into this line. This is actually nice. And let's push that right into the repo. And check out the source code. So everything I do right now on the stream is available on this repo. So if you're interested, you can check it out here. So there's all the source codes for all of the executables and stuff like that. All right, so I think we're finally ready to tackle some issues that I planned for today. So there's this refactoring thing that is not that important, and there we go. So let's work on assembly language, right? Let's introduce the comments. How about that? So right now in our assembly, we don't really support any comments, right? If I add a comment here, it's probably gonna complain. Okay, let's put it like this. Top comment, middle comment, and I also want to have comments like somewhere here. Side comment. Is that an ass farting? It's a good question. Maybe. And if I try to build this entire thing, it will complain. Something like unknown instruction, this. Yeah, you see, we cannot translate this instruction. It's an unknown instruction. Hey Tsoding, I thought you hated Lisp. Well, if you thought so, I would really recommend you to check out FAQ. So there's a question about my favorite language there, and I really recommend you to check out my FAQ. All right, so let's take a look at the bosom. Right, so I think, yeah, somewhere in the translation, I don't really add a new line. Yeah, where was that? Unknown. Yeah, there we go. So I forgot to put a new line here. Yeah, so this is why it appears so weird here, right? So if I put like that, yeah, unknown instruction hash. Unknown instruction hash. And how are we gonna work with all of that? So translate line. So here's we translating line. But what's fun is that we're also ignoring the lines, right? We're also ignoring the lines if the line count is that. Another thing we can check, if the line data equal to that. Hello, here's Car, welcome to the stream. So essentially what we're doing here, we're chopping a line, then we're trimming it, and after trimming that, if it has a comment, it should start with a hash. So, and if it's starting with a hash, we're gonna ignore it. We're gonna definitely ignore it. So that will enable us with having these kind of comments, right? And as you can see, it worked. It actually worked. So, and then I should be able to do BME example fib BM, and it has to be an input. And I go, it works, and then I can actually limit the execution. Oh, by the way, I just realized that I forgot to update readme. Right, I forgot to update readme. So now to call the emulator, you have to call it with the flags, with the corresponding flags and shit. And also, it would be nice to limit the execution, right? So let's go ahead and fix it up. Update readme. So we're updating the readme and we're pushing that right into the repo. Another interesting thing, I think it would be nice to have this comment actually saying something useful. Something like first to Fibonacci. Is that how we spell Fibonacci? I don't know how to spell it. Fib-O, okay. Fibonacci. Numbers. Okay, so and then here we're gonna have the loop, right? So first two Fibonacci numbers and the loop. All right. Fibanana, haha, very funny Fibanana. Okay, but we don't support these kind of comments where you can put something like this, right? What about jump 2? What about it? You tell me. Repeat. There we go. So, and it still works. Look at that. It still works, which is kind of interesting. So it works by default. Why does it work? Let me see. So in bm.h, we have bm translate line, right? Which translates in single line. So what we're doing here, we're chopping off by space. We're chopping off by space. And then the operand that we're chopping off here, we're trimming to the right. Oh, I see what's going on. I see. So it kind of works automatically. Yeah, it kind of works automatically. I can clearly see that. So then we can have a potential operand, I suppose. Because it gets ignored. Happy accident. Yeah, but I don't want to rely on such accidents. I'd rather handle it properly. So how are we gonna do that? So we're gonna have something like operand here. So instruction name and the operand. And we're gonna do a sv chop by delimiter. And the delimiter is going to be the hash. And if we don't have the hash, it's still gonna work. It's still gonna work. And the operand. And we might as well actually trim the whole thing. Yeah, sv trim. Switch up by delimiter. We don't really need to trim that thing. And yeah, there we go. So that means in all of the places where I do this operand thingy, I can now do... Not really. There we go. Sv to int, like this, I think. What if you have a hash as part of the instruction someday? That means I'll have to change the behavior of this this line. Until I don't have hash as a part of the instructions, I'm not going to change it. So that way I can prevent myself from doing the work that is never needed. Okay, so here's the operand, unknown type string. Yeah, there we go. Cool. Seems to be working, seems to be twerking. And let's go to the readme and let's execute that. And couldn't find the file. Really? Examples? Is it because it's fib? Okay, I have a typo in the readme. It's actually very important. How would you connect strings as operands indirectly via labels? I'll just connect them. Okay. So let's fix the typo. Fix typo in readme. There we go. There we go. There we go. And I think we're ready to implement the comments. So here's the issue. Here's the issue that implements the comments. And I'm going to close this issue. So I staged everything. Introduce comments to BASM language. Right, and we're going to close the issue number 1. And let's push that right into the repo. Okay, cool. Seems to be working. Seems to be working. So, and the issue should be automatically closed because I mentioned close that issue in the comment message, you know, GitHub keywords and stuff. The next thing is gonna be labels. Yes, the next thing is gonna be labels. This one is interesting. So we'll need to keep track of the where labels were introduced. And what is their addresses, and maybe we're gonna have like 2 passes or something where we're gonna resolve all of that. Are you okay on that? So let's continue. Labels. So the use case for the labels I have is the following, right? We introduce the loop here, right? So this is going to be the usual thing, and then you just loop back. So you won't be able to use labels on any of the instructions except jump or jump if. So because right now we only have 2 instructions that accept the address of the program, right? An address of the program is the index within the instruction list, right? So let me see. So if I take a look at the definition of the virtual machine, right? The definition of the virtual machine. Here is the program. So this is where we store the instructions for the program, right? And this thing is just basically the index within that array, right? It's just an index within that array. And this is what we need to do here. All right, how can we know what index refers to? What index refers to? We can iterate through the lines, right? And if we encounter a label, right? If we encounter a label, we kind of know the number of the instruction it refers to, right? Because we pushed all of these previous instructions already, we already filled up the machine a little bit. So the index of this label is going to be equal to program size at the moment of translation. It's equal to the program size of the moment of translation. What's interesting is that you might be trying to do things like this, like jump to the loop, right? And for example, if we're translating as one pass, right? If we're translating as one pass, we may not know this thing yet. So we may want to have like these placeholders at some point. You can have a loop dup 1, or do labels have to be one line? It doesn't matter. It doesn't solve the most difficult problem here, Kato. You're focusing on the wrong problem. What you're referring to is not a problem at all. Like, it's non-existent problem. It's already solved. Period. What I'm referring to is this one. So right now we have a one-pass translation, and one-pass translation is incapable of resolving this kind of situation. We are referring to a label that is not defined yet. So we have to look back somehow, like look in the future somehow. That's the real problem. Whatever you're talking about, it's not a problem at all. Like, forget about it. It's easy. This one is difficult. So essentially how we can resolve all of that is probably by having like placeholders for the jump instructions, right? Maybe we're gonna have yeah, we can have another array where we keep the index of the instruction that is not resolved yet and the label it's referring to. Yes, that is cool. Right, that is cool. So essentially, when we encounter a jump, so bm translate line, when we encounter this thing, a jump, we don't set its operand to anything. We set it to 0. But on top of that, we also add a record to a special array that for the instruction, for this particular instruction and this particular index that we're parsing right now, we're referring to this label. When we're done translating everything, we're gonna look through the records we collected and go back to the jump instructions and resolve them. Right. So first we add in a jump instruction without resolving the addresses. That once we have enough information, we do the second pass and resolve them. So this is the most interesting problem, and this is how we're gonna solve it. Yes. Yesu. Kawaii desuka. All right. Now, so we need to come up with the record, right? We need to come up with the record. So how are we gonna call it? So we're gonna call it the label. Yeah, I think that's the perfect name for this thing. It's gonna be label. That's what it's gonna be called, and it's gonna be name. To be fair, we store everything. We store everything in string views, so the name of the label is going to be string view, right? It's going to be definitely string view. Then we also need its address. There we go. So this is the label. Always such easy projects on this channel. Do you really mean easy or do you mean simple? What exactly do you mean? Do you really mean easy? So, and where are we gonna store all of these labels? So we need some sort of an array of these labels. I guess irony is hard to catch in the chat. Okay, so I want to have some sort of a struct where I'm going to have a bunch of labels. Label capacity. Right, so we're going to have some sort of a label capacity, and then we're going to have labels size. So we can sort of like fill it up. Me centering a div in a div is a joke. Well, I mean, centering a div in a div is actually kind of difficult. Well, at least it was like 20 years ago. So, and how are we gonna call the struct that keeps track of the labels? Something like a label table? Holy shit, I love this name, label table. Table label. All right. Label table, and one of the things, and we need to also implement a bunch of operations for this thing. That's for sure. Right. For example, pushing into the label, right, or checking whether the label already contains this thing or not. Is it label table? God damn it. So yeah, it's like a lemon demon, right? You know, lemon demon. Spelling is so similar, but they're pronounced differently, which fucks up with your brain, and this is intentional actually. Lemon demon. It's so fucking bad. Holy fuck. Alright. So, yeah. what kind of operations do we need? Label table contains, right? And we're gonna provide, I guess, the label table itself, label table. We're gonna call it LT as gonna const. And we're also gonna provide the name, right? So we just want to look up a particular name, right? Does it have it? And if it does have it, maybe we should return an index where it's located. But it could be not correct, so that means we want to return integer. Right, we want to return integer. By the way, word. What's the definition of word? Word, it's in 64. Okay. Right. Maybe label, yeah, we're in C. I'm sorry. Okay, so label contains, and another thing I want to implement label table push, right, which will update the label table. And we're gonna put what there? We might as well actually put this pair so you don't have to construct a new thing, right? You don't have to construct anything, right? And this is another thing we'll need to implement. And I think that's it. We don't need any other operations here. So we only need to check whether something contains that or not. So we're gonna be iterating through this entire stuff. So it's gonna be LT label size. This one is gonna be size T. And this is gonna be ++I. We might as well actually do size T, because why not? Alright. And if LT labels I oh yeah, it is generic. Name is equal to the name we're looking for, so we have to use SUQ name. If it's equal, that means we'll have to instantly return size T, actually int I, and here we can return -1. So this is how we're gonna approach all of that. So we can check whether, yeah, it should be called find. So you can find a particular address. So we're looking through this thing. If we find it, we return it. And the next thing we need to do, we need to push it. So, but first we need to assert that LT label size is less than label capacity. So we need to double check that we have enough capacity to even push anything there. So, and then we take the labels. LT label size. Label size is going to be ++, and we are assigning the following thing there. We're assigning a label, name, address. Cool. So that's the only operations we need here, boys and girls. That's the only operations we need. Cool. So what's funny is that where do we keep this label? We can try to keep it on the stack for now, at least. So it's going to be define label capacity is going to be 124 as well. So here it is. Label table. So translating a single line is not going to update anything. So we're also translating a source. We accept the program, and yeah, we're translating it into this array of program. Yeah, I see what we're doing here. So then we translate this line, but the problem here is that we'll have to push into the label table. Okay, so I'm gonna modify the translate source, and I'm gonna make it accept label table. Right, label table LT. So you will have to allocate that label table somewhere, maybe on a static memory, and we're gonna use that thing. We're gonna use that thing. And I think translate line will also need this thing. But I also feel like translate line need the current program size and program capacity. Yeah, it also needs to know the current program size. So maybe we're gonna slightly change this entire thing, and we're gonna accept the virtual machine itself. Right, because you take the source code and we're gonna translate the source code into the program memory of the virtual machine directly. Right, and I think BM translate should accept both BM and label table. Right, but does it really need to modify? Does it really need to modify the virtual machine? I don't think it needs to modify it. It only needs to look up the amount of instructions we already have there, just to push something into the label table. All right, so that makes a little bit more sense now. BM translate source. Let me change the declaration here as well. Hopefully that will be better. Virtual machine, yes. Label table. Okay, so it doesn't have a... Oh, okay, I see. This thing has to be defined in the declaration section of the header. Yes, because we're using like STB style header only library. By the way, for those who doesn't know, STB is actually a pretty cool collection of libraries. So they are header only C libraries, and they have a pretty cool approach. Is that when you import, when you include them, they act like headers without any implementation, right? And you have to define a special macro before them to also generate implementation for you. So, and that's why a single like header only library is kind of split into two sections, the declaration section and the implementation section. And this is exactly what I'm trying to follow here. So yeah, VMH. So I'm gonna put, yeah, like header and CPP file 2 in 1. Yeah, exactly. Or like in Pascal, you have implementation section and, you know, interface section. So, okay. So label table, did I, oh goddammit, actually did a fucky wacky. Yeah, an oopsie doopsie. So what I want to do here is put it like this: BMH, cool, and label table. So have to move this thing to the declaration here as well. BMH. So there we go. So we have these operations. I don't think we need any more operations. And I don't think we do have any more operations. Okay, cool. So let me try to compile all that and go through the old compilation errors and just fix them. So label table, and that's exactly why I wanted to put it here. Yeah. So as you can see, I have like an end of the header in the middle of the file, and then we start in the implementation section. Okay, so oh yeah, that's cool. Label table has no member label size. Did you mean label size? Yes. Label size. Conflicting types BM. Oh, okay. So I suppose the translate BM translate line, yeah, has to be updated here as well. Unused variable BM, that's okay. Unused variable LT, that's okay. What about this thing? Program capacity. Okay, so we have to use something like program capacity here. And instead of the program size, what we're doing, we do something like this. Yeah, program size. Then we're pushing an instruction there. But I think we even have BM push. Something about push instruction, I forgot. I think I removed it. Yeah, I think I removed that function. Yeah, there was like an actually convenient function that would push an instruction, and I think I removed it at some point. But okay, it is what it is. Okay, program this thing, and then I translate in it, but also I put a BM here and LT. So what's funny is that it's kind of dangerous, like I'm modifying BM here, and I put BM into this function, which can potentially modify BM, and this looks like undefined behavior, but BM here is const. So this function will never modify BM. BM is never modified on the right part. So it's only modified on the left one, which is kind of cool. This is exactly the moment when these like const qualifiers are actually useful. Anyways. Okay, what else do we have here? This is all right, and we are returning a program science. But to be fair, since we're providing the whole virtual machine here, we don't have to return anything, I think. Another thing, when we're translating source in the virtual machine, I think it's quite important to notice to clean up the program size. So we basically wipe out the whole program, and there we go. Okay, so another unused parameter, and yeah, another conflicting types, because this one is just void now. But that const does not forward for modifying BM. Does not guard. You mean does not guard? Is that what you're trying to say? Okay, so this is what we have to do here. Sure. It doesn't guard for anything. Okay. It's almost like you have to be disciplined to program in C, am I right? It's almost like you have to know what you're doing. Okay, so we also need to put a label table. Right, label table. And we're gonna put this thing here. It's crazy. It's fucking crazy. You have to really know what you're doing when you're programming. Holy shit. Yeah. Void. Okay. So I don't have to do that anymore. Yeah. So we're translating the source into the BM, right? And then we're saving it to the file. Cool, cool, cool. Nice. I like to program in C without even knowing what I'm doing. It should be /const, but not const. No, I don't think so. Okay. When we encounter a jump, all right. When we encounter a jump, we are not going to... Okay, so the operand has to be... just try to change program size. No, I don't think so. No. It's kind of interesting. Like, I keep ignoring you, right? You really want to waste my time. You just keep pushing. God damn it. Okay, so when you have const before star, you have a const pointer, but not const variable. So I cannot do this thing, right? But I can do these things. But it is not important, because the only thing I'm guarding here is the memory to which the pointer is pointing, not the variable itself. I don't care if the variable is modifiable within the function. What I care about is whether this pointer pointing to the protected memory, right? So, all right. So let's continue. What I'm thinking is... when I have jump, so for the jumps we have to support both addresses and labels, addresses and labels, which is kind of interesting. So label points to that. Oh yeah, this one is actually kind of interesting. So let's make a cup of tea. Let's make a cup of tea. I think I need to reset my chat. Are you bullying somebody? Stop bullying. It's against US. We are educational channel, okay? No bullying. We're against bullying, harassment, and everything bad. We are only educating people, okay? What would be an example of real life use for const? When maybe let me show you. For example, you have this binding within a program, but what the problem is here is that it's modifiable, right? But you have no plans to modify it throughout the whole body of the function, so you might as well also mark it as const. You see? A little toxicity. No toxicity is allowed. If you are toxic, you're gonna be perma-banned from this channel. So yeah. Go. No toxicity in the city. What's up, Shade3TV? Welcome to the stream. Alright. I'm gonna make a cup of tea. Does anyone have any questions? What key switch? I think it's something Topra or something. I'm using HHKB. So I think they use Topra. I'm not a big like keyboard nerd. So I got this keyboard as my birthday gift from my parents a long time ago, and to be fair, I would never buy such keyboard myself. I don't tend to like spend too much money on myself, so yeah. I remember you once told us Russians are slightly toxic as a survival technique. So what? Speaking of keyboard, ever think about building one? Well, I just said like a minute ago, I'm not a big keyboard nerd and I would never buy myself a Topper keyboard. So I guess the answer is yes, I like building keyboards. I'm a big fan of keyboards. Oh my god. Definitely, I'm gonna build a keyboard one day. You really like my Haskell videos on YouTube? Thank you. I worked really hard on them, especially editing them is really like takes a lot of time, to be fair. And I'm glad that some people find them useful. Building one is gonna be cheaper. It's not about the price, it's about the fact that I'm like cannot justify it for myself. Right? I don't know. Okay. So I'm gonna go to the kitchen quickly, real quick. Right? I'm gonna turn on the kettle. You don't go anywhere, or I will come to your house, steal all of your source code, and make all of your variables constant. Okay? And then I'm a Haskeller. I know how to make all of the variables constant. Okay? So trust me, I know how to do that. I came. What's up? What's up, Epic Gamers? Now, let's continue. What is going on? Okay, cool. So what we were doing, by the way, we were trying to compile the program, right? Okay, the program compiles. Oh, that's interesting. Unknown instruction loop. That's what I'm talking about, mate. what I'm talking about, bro. So how are we gonna even do all of that? I'm thinking of actually changing the way we're gonna parse all of that. Changing the way we're gonna parse all of that. How we're gonna parse all of that? BM translate a line. So we need to distinguish, chat. We need to distinguish between just irregular things and labels. So in case of labels, the inst name is going to be ending with colon. But can you have like a spaces between the name and the colon? I don't think you can have spaces between the names and the colon. So is that a thing in other ASMs? To be fair, I don't think it matters. I don't think it matters that much. So that means we're gonna just do that. We're gonna just do that. So if inst name, first of all, it's quite important to check that the count is actually greater than 0, right? It's greater than 0, and inst name data, is it data? Something like that. Data minus 1 equal to that. That means we hit the jackpot. We hit the label. There we go. Just be strict, no spaces allowed. So maybe I just have to take some sort of a, how is it called? A recursive descent approach. Maybe I need to first tokenize things. But I don't really want to go that route because I want you to quickly hack together like a simple assembly language without too much hassle. And I'm pretty sure it's going to bite me in the ass in the future. But it is what it is. It is what it is. And also we don't support the labels on the same line. What the fuck? I just got rickrolled by Alexei Kutepov. What do? What? Who's that? Who's Alexei Kutepov? I don't know who that is. So if it's equal to that, I wanna create the following thing. So it's gonna be string view label, right? We're gonna initialize that. The count is gonna be instruction name count minus 1, but the data is gonna be instruction name data. There we go, we have a label. And that label is located. That label is located at BM program size address. So, and that's essentially what we're gonna do. What we're gonna do label table push. Was it push label table? I think it was just push. Yeah, it was just push. So it's gonna be LT, and I forgot the definition of this thing. Yeah, it's name. We do know the name. It's label, and the address is gonna be program size. There we go. This is how we do that. We encounter the label and we push that instruction. We push that instruction there. And there we go. There we go. But we also need to keep track of all of the like jump references that we have to resolve later. Right. We also need to keep track of those as well, because we're kind of losing this information. Okay, so here's an idea. So if we encounter a jump, we're setting this operand to nothing. As a matter of fact, we just do that, right? So we just set it to nothing. And after that, I want to do a simple dump. So we translate the source. Afterwards, I'm going to iterate through all of the labels, label size, and I'm going to just print their addresses. So it's going to print F. So we have to be a little bit careful. I think it has to be like this, and the address is going to be like this. So LT labels I count So because they're sized strings, you have to be super careful about that. Then data, and then LT labels I, address. There we go. So, and let's try to translate all of that. So there's a count. Doesn't have count. Ah. Excuse me. There we go. So as you can see, it detected the loop label. It detected the loop label, and it knows that it's an address 4. And if we take a look at the fib here, I don't think it's correct. 1, 2, 3, 0, 1, 2. It has to be 3 actually. So yeah, my tea is ready, by the way. My tea is ready. I'm gonna quickly go to the kitchen and you know, get some hot water. Don't go anywhere, or I'm gonna resolve all of your labels. Off by 1 error, kick double, yes. Off boy 1, off boy 1. How are you guys doing today? I'm doing quite well, just got myself some tea, and minus 15, holy fuck. I can feel it. I can feel it that it's actually quite warm in here. Nice. By the way, there's something wrong with my window frame. That's probably why it's so cold inside. Maybe like the extreme cold, you know, broke something, because it was actually fine up until like minus 25. Like I was at my apartment at minus 25, it was completely fine, and now at minus 50 it's kind of cold. I have a feeling that maybe extreme cold, like at minus 40, did something with the window frame. Like, what the fuck? So, I'll probably need to do something about that at some point. Unfortunately, don't want to die due to being frozen. Alrighty. Minus 15. No, we had minus 40. I think the record, like for the past several days, was minus 48 at night or something. Windows leaking, classic. Haha. I feel minus 12 too. I had to close my window. Very funny. Very funny. Okay, so what are we doing here? Oh, I think it is an undefined behavior after all. It was an undefined behavior after all, because, oh, for fuck's sake. Well, I mean, unironically, by the way, unironically, borrow checker would have prevented that. Like, I'm not even joking right now. In Rust, you wouldn't be able to do something like this, because you're trying to borrow this thing, and like for writing, right? You're trying to borrow it for writing and also borrow it for reading, and you literally cannot do that in Rust due to borrow checker, and it would actually prevent this error, and it would ask you to separate these two. Holy fuck. Like, unironically, borrow checker would have prevented it. How about that? Ah, amazing. Can your C do that? Yeah, exactly. Can your C do that? So, and it actually resolved the label correctly, as you can see. See, it's resolved correctly. We also need to do a little bit of casting here. Control reaches the end. Yep. So unknown instruction, and okay, this one is interesting. So it's never gonna really reach the end. Never gonna reach the end, but we might as well just return like an empty instruction, I suppose. Is it gonna work? It's not gonna work, but we can do something like inst. How did it work before though? It's very strange. Ah, I know why. Okay, so when we're translating, yeah, okay. not every translate line is gonna work. So we have to refactor this entire thing. Not even sure if it makes sense for me to even maintain this function. Maybe it would be better to inline it. I think I'm gonna just go ahead and inline this entire thing because it doesn't really make much sense anymore. So here is the translate line, right? And I'm inlining it here. So here's the line. We already trimming it here, so we don't need that thing anymore. Then we have line. We do everything here. So at some point we do need to add those instructions. At some point we don't need to add them. So I think I'm gonna just quickly do this thing where I just assign it like so. So, and maybe I can even do things like that. We're gonna do up, up, up. There we go. Cool. So we also have an operand. And I'm thinking that it depends on the operand, to be fair. Why do we do that? This is actually really strange. So this is a label, we put that a label. We already push this operand. If it's push, we do this thing like that. There we go. If it's a dupe, we push this thing like that. What's up, Gilchristen? Welcome to the stream. So, so far so good. I really like how it's going. So I just need to clean up some of these things. And it even looks decent, I think. This code even looks decent. Right, so you encounter a label, you just do that. If you encounter an instruction, you push that instruction. Cool. Nice, I like that. So how about this? So, and we don't need this function anymore, by the way. So I think I have a forward declaration for it here. We don't need it. Yeah, we can just remove all of this stuff here. Nice. And yeah, there we go. So we have this thing and it was resolved correctly. How about that? So now I need to go back to all of the jumps and resolve them appropriately. I need to resolve them appropriately. But the question is how we're going to resolve them. We need to store. You could make something for it. There is an emulator. Are you talking to me? I'm not sure who you're talking to. All right. So here are all of the labels, right? And I also need to keep track of all of the jumps, right? I also need to keep track of all of the jumps, their positions, and what they're referring to. So let me create another structure here. Unresolved resolved jump, or maybe unresolved jump. Right, so we're gonna have an address of where that jump is located, right, in the program, right, where it's located, and what label it's trying to jump, right? So you see, these two things are like look very similar, but they semantically different. They are actually semantically different, and I even like ordered. Yeah, I think I'm gonna call it like this. Yeah, label, right? They're semantically different. It's basically locations of all of the jumps that have unresolved labels. So, and we can probably actually keep them here. So unresolved jump, unresolved jumps, and we can have unresolved jumps capacity at some point as well. All right. Yeah. Yesu. And then we're gonna have unresolved jumps size. And there we go. And this is quite important. So after translating everything, we're gonna iterate through unresolved jumps and then resolve their jumps according to the label table that we collected, right? Make sense? Makes sense. All right, but we also need things like label table, push, unresolved jump, right? Push unresolved jump. So it will accept actually different order, right? So the address of the jump and the name of the table that is used, of the label that is used by this thing. So I'm going to rename this thing a little bit later, right? Because I think this should not be called label table because it contains not only labels but also the positions of unresolved jumps. Maybe it's going to be translation context. I think this is a better name for this thing because it's literally what it is, a translation context, because it needs to keep track of the label addresses, unresolved jumps positions, and so on and so forth. So yeah, it's going to be a translation context. Okay, let me go and implement this function. So I'm going to go to the label table push. Here's the label table push, and here we have a label table unresolved jump, push unresolved jump. And this is kind of similar, except we need to rename labels with unresolved jumps, like this. Unresolved jumps size. And in here we have an unresolved jump. Instead of name we have label, instead of address we have the address, and we might as well actually change the order. Even though we're using designated initializers, we don't have to change the order, but I still want to do that anyway. Does not compile, forgot some things. Yeah, I forgot to define this magical constant, so we're gonna have 124. All right, unresolved jumps undeclared, but I just declared it. Oh, it has to be a capacity. Coach, other session from the beginning, nice work. So we can always follow my VODs channel here. I upload all of the streams to that YouTube channel. So yeah, so you can always watch it there, because I know that it's a little bit more convenient to watch videos on YouTube rather than on Twitch. So Twitch is more for live streams. For offline content, YouTube is a little bit better. All right, are you guys ready for a little bit of TSMR? Let's do a little bit of TSMR. Okay. So let's continue. And is it going to compile? So unresolved jump, single one, and it works. Cool. So now every time I'm translating this thing, every time I'm, for example, pushing a jump, I also have to push unresolved jump, because this jump is obviously not resolved. Is it coffee? No, it's tea. I just overstepped it. So label table push unresolved jump, and we push it into the label table. The name of the table is actually the operand. Yeah, it is actually the operand, but it kind of depends. So we're gonna put this as the name of the label. It's a non-coffee caffeinated drink. Yeah, exactly. That's what it is. And the address of the jump is a program size. So this is how we do that. And then we push an instruction. So here we have, yeah. So every time we have a jump, we have unresolved jumps. Okay. So let's do this thing. Labels. Here they are. Print F. Unresolved jumps. Cool. And now I want to iterate through unresolved jumps. LT unresolved jumps size. And we're gonna do a similar thing here, but with unresolved jumps. So how are we gonna do that? So first we have to do an address. address of a jump, and then its label it's referring to, right? So that means I have to do this thing first. So this is address, but this is not labels, by the way. It has to be unresolved jumps. So it has address, but instead of name here, it has to refer to a label. Cool. It doesn't compile because operand incompatible type 2 long int. Oh, okay. So it has to be like this then. All right, and of course, it expects to have something like LD. Yeah. It expects something like LD. And okay, so unresolved jumps. Very interesting. So here we're looking at the Fibonacci, right? Here we're looking at the Fibonacci translation. So let's go to the Fibonacci. There we go. We have two jumps here. We have two jumps, and both of them refer to loop. Both of them refer to loop, and these are their addresses. These are their addresses. On top of that, here are all of the labels. So we have only one label. So the thing we'll have to do here, we'll have to iterate through all of the unresolved jumps and replace their labels with the address here. We have enough information to do that. Are there Russian energy drinks like Monster or Red Bull? We do have Red Bull in Russia. I don't remember seeing Monster drinks, to be fair. I think we do have Monster drinks, yes. We have them, okay. I just don't drink them, so that's why I don't really look for them in the grocery stores. Yeah. Me neither. I think it's called Stalish. Yeah, it's a Russian energy drink, Russian standard. Oh, you mean like produced by Russian companies? Is that what you mean? Oh, I don't know. Do we have any specific Russian energy drinks? I don't think so. Some are mixing Red Bull with vodka here. Well, it's not really healthy. Mixing up alcohol and caffeine is like the least healthy thing you can do. And use energy drink when you have vodka. Exactly. I don't know, I don't need energy drinks. I just drink very strong tea, and it just kind of replaces energy drinks for me. Yeah. Okay, so let's actually do that. Let's iterate through unresolved jumps after the translation and replace their operands to the corresponding addresses. Okay, so this is how we're going to do that. We don't need any of these dumps anymore. Okay, so here's the whole translation. We're just iterating through the whole source code, and we're just translating everything. So then the next step is to iterate through all of the unresolved jumps. Label table. Unresolved jumps count. Don't mix caffeine and alcohol, my friend got in coma. Yeah, exactly. It's actually super fucking dangerous. As far as I know, in US, like any products that are mix of alcohol and caffeine are straight forbidden. I think also in Russia. I think it's also forbidden in Russia. Yeah, like at some point, like in early zeros and 90s, we had a drink called Jaguar, which is mix of alcohol and caffeine, and at some point it was fucking forbidden. Like banned. What verb is used for this thing? Prohibited, I suppose. Yeah, I'm just looking for a proper verb. Yeah, too many verbs. I don't know which one to choose. So let me see. So we're going through all of the unresolved jumps, and in a label table, we take the unresolved jump, I, and we take a look at its address. Right, so here's the address of the unresolved jump. So the next thing we do, in the virtual machine, we take the program and we obtain the instruction at that particular address. You see, we have unresolved jump and we know its address. We obtain this instruction. We obtain this instruction. So what we need to do is to set the operand of that particular instruction to the correct address. But the question is where we can take that correct address. Well, in the same unresolved jump, we have a label, right? We have a label. So, and we have an operation label table find, where you can provide the label table and the label you're looking for, like the label you're looking for, and it will return you the address of that label. Well, at least it's supposed to, as far as I know. Yeah, it should return you like an index inside of a label. I think I'm gonna actually go ahead and change this thing at some point. So we're gonna have a word and it's gonna be address, right? It's gonna be address. So this is the address of this label, right? Of this label. And what we're doing with that address, we're just straight up assigning it to the operand of that instruction. And this is how we resolve all of these unresolved jumps. This is how we resolve these labels. And this will enable us with referring to the labels that are not declared yet. So basically, this will enable us with jumping forward. You know what I mean? Right? Because we do need situations like this. I can jump to the loop, right? Right, but it's only defined later. How can I jump there? Like, there's no way for me to jump there. So, well, we defer the resolution of the label addresses up until the end of the translation. And after that, we're going through all of the unresolved jumps and we're replacing everything. So that's how we do that. Yeah. Hopefully that will work. We'll see. We'll see how it's gonna work. Okay. So is it gonna compile? Is it? Oh yeah, I forgot to actually change the interface of this function. I think it should just return the address right away. It doesn't need to return like anything else. So it's gonna be like this, and once we get, so this could be like a word. So we just return I, and in this particular case, we can just do something like assert. Let me think. fprintf, std error, this thing, label, this specific label, right? This specific label does not exist, right? And then we can just exit with 1. We can just fail because it doesn't matter. We're trying to refer to the label that doesn't exist. All right, so name, we're gonna have count is gonna be integer, and name data. There we go. So let me see. Okay, I updated all of these signatures here. Let's see if it's gonna compile. So label size is, might as well also convert it to Word for now. Probably gonna refactor it later, so it doesn't matter. Unresolved jumps, label, table, and declared. Really? Oh, it's called LT. I keep forgetting that it's called LT instead because I actually shorten it. So let me see. Can I take this thing? It's gonna be LT like this. So, and this is just LT, and I can squash it like that. There we go. I think it worked. Cool. So let's see if it actually worked. How about that? Is it gonna be first try gut Kuder moment, or is it gonna be yet another failure? We about to find out. So look, here is the source code of the Fibonacci program, right? You have this jump that jumps here, you have this label, and you have this jump that jumps back, and stuff like that, right? So what I'm doing here, I'm compiling this, I'm rather translating it, right? So it translated without any errors, and here is well, I mean, we can do something like hex dump. Here is the bytecode of this entire stuff. It's just a bytecode. So the next step we can do, we can try to disassemble it and verify that the labels were resolved correctly. So it's going to be debusm, right? And jump 0, they were not. I'm super happy. Okay, so the question is, what the fuck happened? I think I know what the fuck happened. Instead of returning an actual address, I'm returning index. So what I have to return is an address of the label. That's what I have to return. I'm an idiot. Okay, and because of that, I can just do size t here without any problems. So I still on part 1. Still, god damn it. All right, one more time. One more time. Okay, so we're generating this thing, and let's take a look. Well, I mean, I have to use hex dump c. Here it is, and let's do debusm. Let's do debusm. It's gonna be fib bm, and look at that, jump 3. And let's take a look at the example fib busm here. Right, so loop is pointing at this instruction. They're numbered from 0, 0, 1, 2, 3. So here we have 2 jumps, jump 3 and jump 3. So the label got resolved correctly. How about that? Where is the PogChamps? I'm waiting for PogChamps. It's a first try, motherfucker. Yes, it is first try. I mean, it's technically first try. Yeah, so we're correctly resolving labels and shit. I just got here, I have no idea, but Pog, yes. So essentially what we're doing, we're implementing an assembly for our virtual machine, and our assembly supports labels, and we resolve the addresses of the labels correctly. Which is kind of difficult because you have like one pass compiler, translator, so you need some sort of like a second pass. Well, does it make our translator 2-pass translator? I think it kind of does, if you think about it. Right, so translate, look, so we do the first pass, we go through the source code, and then this is the second pass, I suppose. You can actually kind of, do something like this, like first pass, and here's the second pass. Right, on the second pass we resolve all of these addresses and stuff like that. 1.5, I guess, but we're not going through the whole program, we're only going through the unresolved jumps, so which is kind of important to keep in mind. So it's unresolved jumps. Okay, it's kind of cool, not gonna lie. But by the way, in here, fib busm, so this jump is actually invalid. It actually makes the program incorrect. We shouldn't have it. Not a single pass compiler for ASM. Yeah. Alright, it's kind of cool. I never actually written like assembly translators, and this is something new for me. And I'm actually discovering a lot of interesting things. To be fair, this like label resolving mechanism sounds like a pretty cool problem for Advent of Code. Not gonna lie. Seriously, like I solved like a you know, the 7th day of Advent of Code essentially, because that's what it feels like. All right, because you need to maintain the labels, then you have to go back to the labels and stuff like that. That's an infinite loop, right? Yes, it is an infinite loop. So let's actually try to compile it one more time. So here's the compiler, and let's actually decompile it. And yeah, this is an infinite loop. But our emulator supports a pretty cool thing. It supports the limit for how long it should evaluate, like how many iterations it should perform. So what you can essentially do, you can provide the input of the compiled program, and then you can set the limit to 69. And after 69 cycles, it will just stop and show you the stack of this thing. And for example, I just generated a bunch of Fibonacci numbers, and yep, that got generated from this program, right? So this is a program that generates like Fibonacci numbers. We compile it to bytecode, which you can find essentially here, right? I think it's not located here anymore, somewhere in fibs bm. Yeah, there we go. Here's the bytecode, and we simulating it, emulating it, and so on and so forth. So maybe we should implement like a Fibonacci with condition that breaks out of the loop. But to be fair, I'm not sure how to implement that properly. I'll have to think. By the way, our current code makes it impossible to use absolute addresses instead of labels. Right. So my idea was that you can take the result of the debusm, right, the result of the debusm, and basically pipe it into ASM again and use it. Again, busm. And if we try to do the busm on this, right, busm, input is going to be again busm, again bm. It's not gonna work because label 2 does not exist, because it treats every operand in jump as a label, but it cannot find that label. So here's the problem. So we need to support both absolute addresses and the labels. Prefix absolute address. God damn it. I mean, why? I can just check that the name consists only of digits. I can even make it simpler than that. I can check only first digit, a first character, and if it's a digit, I'm gonna treat it as a number, right? A TT syntax. Yes. A TT syntax. All right, so we need to do something about that. Okay. Why does it keep saving that? Boom. Cool. We need to commit all of that. Starts with a digit, must be a number. Exactly. Like classical language logic, am I right? So that's why in a lot of languages you cannot have identifiers that start with numbers. Luke Gorilla, welcome to the stream. Hello, hello. Okay, so let's create a separate branch where I'm gonna push all of my changes. You know what? I already mentioned that this problem sounds like advent of code problem. I've done a lot of competitive programming in the past. I'm not really good at it, right? I'm not really good at it, but I've done like fair share of competitive programming in the past. I still do that occasionally. But here's the thing. I never made competitive programming problems myself. I never designed them. I don't know how, like, what it's all about. So I'm thinking that maybe I should start collecting these ideas. Basically, if something sounds like a pretty good like competitive programming problem, maybe I should write it down, and at some point maybe I should design a set of problems and organize some sort of a contest or something like that. Sojing's code forces contest. Maybe is Mike open for contests? But to be fair, I don't know if I will be able to create like a good contest. Maybe it's gonna be like div 3 or something like that. I don't know. I think I'm gonna start like collecting the problems and see if I can like turn it into something interesting. Yeah. You can create a group. Oh, okay. So it doesn't have to be like, it can be like for a specific group of people. Huh. That's a cool idea. Design a part 2 now. But I don't know when it's gonna happen, okay? So I don't know. No, I'm not gonna promise anything. So it's just an interesting idea. All right. I think it's maybe so hard to create one contest, but one every year sounds really hard. Well, on the scale of advent of code, yeah. Make sure you come up with some dumb story about the crap. I don't know. We'll see. I don't really like these story descriptions as well, so maybe I'm gonna be straight to the point. Don't really like artificial obscurity of the problems. I don't think it's a good way to do that. But maybe I say that because I never designed problems myself, right? So maybe if I try to design a problem myself, I will realize that there's not much I can do about increasing complexity of the problem, but making the description more obscure. So we'll see. All right. So we introduced the labels to the assembly. Implement labels for assembly. There we go. I'm going to push that right into the repo. But attention retention, zoomers will drop out without cool stories to keep them engaged. Maybe. We'll see. Okay, so the next thing we need to do. First number of tests. Yeah, it's a classic code force. I need to bring back the ability to jump to an absolute address. So we definitely need to have that. We definitely need to have that. So let's do something like this. I'm gonna introduce jump 1. So essentially this jumps to this instruction. It literally jumps to the next instruction. Okay, so and we can try to do that. Just like a baking competition, you can have the great sodium code of get cooking. Isn't it like a thing on Code Chief? They have these code offs competitions, I think, don't they? I think this idea of was already taken. I think it was already taken. Code Chief code off. It's a cook off. Ah, well, I mean, okay. It's not really. Relative jumps, Sibin. Yeah, we'll see. But yeah, right now I want to support like 2 kind of jumps, like jump to a specific label, right, and just have the label somewhere here, and jump by absolute address, because I want to be able to take the output of the bosom, right, and put it back into the bosom. What is SIP? I think it has something to do with maybe encoding x86, maybe, again? I don't know. I'm too dumb for that, I'm sorry. Scale index base. I see. I think I vaguely remember about it. Alright, so what do I need to do? So here's the jump, and operand could be either a label or an address. So if operand count is greater than 0 and operand data is digit, right, we're gonna treat it as the absolute address. So that means what we're gonna do is essentially just push an instruction to the program with already resolved operand. So, and the operand is going to equal to string to integer from that operand. There we go. Otherwise, we're going to treat the operand as a label. We're going to treat it as a label. What that means? That means we're going to push the instruction to the unresolved jumps for a later resolution. And we're going to push this instruction here, but we're not going to provide the operand. You see? So essentially, if you have jump to a specific address, you're not getting pushed into the unresolved jumps, so you're not going to be affected by the second pass, right? You're only going to be affected by the second pass if you're referring to a label. Make sense? It's actually as easy as that, I think. I think it's as easy as that. So let's try to compile this entire thing. And let me see. It does in fact compile. All right, so let's take a look at the example. So examples fib bosom. Here's the bosom. Then we do bosom input example fib bosom, and the output is going to be fib bm. Cool. Now we're going to do the bosom fib bm. And there you go. We still have jump 1, but loop refers to the third instruction here, which is jump 3. Is it really jump 3 though? 0, 1, 2. It is 3. It is actually 3. Can we add a bunch of nonsense to actually test this stuff? I think I want to add a bunch of nonsense. For example, nop. Nop, and that should affect the address of the loop. That should definitely affect the address of the loop. Some nonsense to test label resolution, right? So we're gonna try to compile that, and a known instruction nop. we don't have a translation for it because I haven't implemented it. So I only implemented the instructions that I need. So the instructions that I don't implement it, I just didn't need before. So now I just need to implement them. Okay, so it should be pretty straightforward. If the instruction is equal to NOP, what we're gonna do, we're gonna just push the NOP like this. So we're just pushing the NOP. We don't need an operand, and it's gonna be just NOP. There we go. Cool. And let me try to do that and that. And as you can see, jump 1 stayed the same, but the looping jump became 6. Right, the looping jump became 6. And now we can try to see if it will execute correctly. So we're gonna do BME, and this is gonna be the input, and the limit is gonna be 69, and it still works. Actually, since we have more instructions, we calculated less numbers. But we still calculated some numbers. Okay, cool. Works. It actually works. And what that means is that I can just take BM, right? I can just take BM, debusm it. So this is my debusm, and I can put it into busm again. Right, here's the again busm, and I can busm it again. Right, so it's gonna be again BM, completely correct. So, and I can hex dump it. Cool. And then let's check and at debusm. Cool. So you see, I can just take the output of debusm and put it into the asm again, and it will still properly translate. So this is what I'm going for. So the formats has to be like, you know, compatible with each other. So that's why we support both labels and the absolute values, because the debusm only knows about absolute values because we don't have any label information into the bytecode, right? So it's not a thing. It's pretty cool. It's pretty cool. So let's do a compilation here. Okay. So we can actually do this as a separate thing. So I need to remove again busm. Add support for NOP instruction in assembly. In the assembly, we have a very specific assembly here, and add support for absolute jumps in the assembly. There we go, and let's push that right into the repo. Idempotent busm, yes, that's the 5-head word I was looking for. Thank you so much. Cool, but there's another thing that we don't support, and it's the labels on the same row. It's the labels on the same row. Let me show you what I mean. Right now, you cannot do something like this. You just cannot do that. But I think in the assembly, like in the NASMs and other places, you should be able to do things like that. So let me see if I can do that. It actually worked, but I think it worked incorrectly. I think I know what happened. What headphones do you use? It's like Audio Technica 50 something something something. Oh, you're not asking me. I'm sorry. Okay, so if we take a look at the debusm. At the debusm, and it's going to be fips bm. I think we lost a couple of instructions. Yeah, we lost one dupe. Yeah, basically what happened, we just chopped off this part of the line, recognized it as a label, and ignored everything else afterwards. So that's basically what happened. That is basically what happened, and maybe this is something that we shouldn't do. Yeah, but probably we'll need to fix that at some point. How can we even do that? Cheers, by the way. So the last step to become gut coders is to add support for labels on the same line. That's the last step we need to take to achieve the gut coderness, the gutness coderness. How are we gonna do all of that? Should be pretty straightforward. The godhood. Yeah, that's a better word. Thank you so much. Yeah. So essentially, we can do it like this, I think. We can do it like this. We can separate this kind of logic. Are you going to add registers, or it will be only stack based? I think it's going to be only stack based. So I compensate the lack of registers with an ability to access the stack at randomly. Yes. We'll see, I haven't decided yet. So I'm gonna try to implement more programs in this virtual machine, and I'm gonna take a look at the use cases that I'm gonna have. And if these use cases will require to have registers and I won't be able to achieve the same without the registers, only then I'm gonna add them. I just don't have enough information right now to answer whether I'm gonna have registers or not. You see what I mean? But I rather prefer to implement as least amount of features as possible. So your stack is just a memory with the default access depth of 0? Yeah, I guess. So, but on top of a stack, I'm gonna also have a heap. I'm also gonna have a heap. And heap is gonna be accessible through some of the instructions. So the way you're gonna access the heap is you're gonna push an address in a heap onto the stack, and then you're gonna have an instruction, get a byte at that address, right? And what it will do, it will pop out the address, take the byte, and put that byte onto your stack. So this is how it's gonna work, right? So yeah, you're gonna have stack and you're gonna have a heap, right? And maybe to know the address on the heap, by the way, to know the address on the heap, you're also gonna have an instruction that allocates a memory on the heap. So we're gonna push, for example, the size, and then you have instruction allocate, and that instruction consumes the size and pushes on the stack address at which it allocated something, and then you can use that address to further access this address in the heap, and so on and so forth. So this is how we're gonna have like a heap with a random access. And what's funny is that when I'm gonna implement the allocate instruction, it will literally translate to libcmalloc. I'm not even fucking joking. It's literally gonna be like libcmalloc. So through this interface, you will be able to interact with C runtime. Yeah, it is actually very interesting. So yeah, essentially you have a separate memory for storing instructions, separate memory for storing stack, and heap is just the memory of the computer. It's just a regular memory of the computer. So that's going to be the idea. And through that, you will be able to interact with native environment and stuff like that. Do you have some way? Yes. Essentially, I'm going to have an instruction. You push an address of a function on the stack, and through instruction you can call that function natively, and you can also push arguments for that function on the stack as well. So you can push address and arguments and then say call that natively, and it will pop out everything. It will take the pointer and it will just call it natively, and then you can get the results. So this is the idea. This is like a rough idea. I don't know how exactly I'm going to implement all of that, but that's going to be the idea. In fact, BM is ROSC. I don't even know what ROSC. Let me see. What is ROSC? Return of spontaneous circulation. Okay. Architecture. Reduced operand set computer. Oh yeah, because I have like a 1 operand max. To be fair, I don't think we're gonna have any instructions with more than 1 operand, because if it needs more, you can just put them on the stack. That's kind of the idea. I see. So usually stack-based machines, they don't have like more than 1 operand, again, because it's just not needed. Okay. So just put them on the stack forehead. Yeah. Okay, so I need to add support for these labels, right? We still need to achieve godhood of codeness by implementing these kind of labels, right? Okay, so here what we have here, inst name operand. Maybe we don't even need this thing here. I'm gonna put it somewhere here. All right, so here is the name, and if this name ends with this thing, we know that we detected a label. We know that we detected a label, and that means that we need to try to repeat. We need to try to repeat the extraction of the name, right? So that means we have to repeat this thing. So we try to repeat the instruction of the name, extraction of the name. And if it succeeds, then we take also the operand. So I suppose chop by delimiter. So we also trim everything here, so that means the second one also has to be trimmed. Yep. And if inst name count greater than 0, we'll have to do it like this. Oh my god. Come on, Emacs. I think that's the easiest way to achieve all of that. Right, we first, if we detect this being a label, we take it as a label and we sort of advance the parsing and we try to interpret it as the instruction name yet again. Okay, so now if I take a look at this thing, it does include the dupe. Look at that. It does include the dupe. We didn't lose anything. Isn't that amazing? Isn't that amazing? I think it's goddamn amazing. And in fib, we can even have something like this. So the loop, and I can try to compile it yet again. And it's still correct. It is still correct. And I can move the label here, right? And I'm gonna try to recompile it. And it's still correct. Cool. So we fixed it. So there's a lot of hacks in here, but overall, I think it works okay. So maybe I'm gonna clean up it afterwards. But the main, you know, the main stuff, the main features work, and we have a proper assembly in which we can program, in which we can inspect and ensure that it works correct and stuff like that. So yeah, I'm super happy about that. Implement support for the labels on the same line with inst. Let's push that right into the repo, and the source code for everything I do on the stream you can find here if you're interested, of course. So this virtual machine is open source. It is open source. Okay, guys. And the thing I want to do now, I want to refactor some of the stuff. Specifically, I want to rename this structure because I don't think it reflects its intention. Hello, Panupudi, welcome to the stream. How are you doing? How are you doing? All right, so what we're gonna have. So it's more of a translation context, if you think about it. It's more of a translation context. But to be fair, like translation context is kind of a long word. So we can call it maybe bosom context. We need bosom context. Well, it could be called just bosom then. Bosom context, so it's for bosom. What's the meaning of refactor? You can Google it up. Refactoring. Code refactoring. Let's read about it. In computer programming and software design, code refactoring is the process of restructuring existing computer code, changing the factoring, without changing its external behavior. Refactoring is intended to improve the design structure and/or implementation of the software while preserving its functionality. Does it make sense? Yeah. Emacs config, yes, my Emacs config is available on the GitHub, you can find it here. It's when you factor a number and then multiply prime multiplications, yes. What do you think about SecD machines? I never heard about them, I'm sorry. I'm not really smart. Okay, so I'm gonna call it bosom, and this is essentially a bosom context, right? So that's what it is. I also want to rename unresolved jumps, right? Unresolved jumps, because they may not necessarily be jumps actually. They could be any instructions which operand accepts the program address. That's what it could be. So I don't think it has to have anything to do like with jumps. So there should be a better name for these kind of things. Unresolved label? No, it's actually what we're referring to. We're referring like with this address. This is an address of an instruction, the operand of which refers to the label. So this is quite important. Address of an instruction, the operand of which refers to a label. That's what it is. So it's not necessarily label, it is not necessarily jump. Fix up, maybe. So so what I'm thinking is that the name should definitely contain operand, right? Unresolved address. But whether it's gonna be fix up, whether it's gonna be something else, I'm not sure. Like, I don't really speak English that well to actually consider fix up intuitive enough. It's some sort of like a delayed operand label, maybe. Deferred operand. It's still kind of long. Is that a good name? Refers labels. Okay, yeah, maybe. Deferred operands. Okay. It's even longer than a resolved jump. I'm not gonna lie. It's even longer than that. Yeah, it's longer. Maybe we can call it deferred then. But then we lose a lot of information. Deferred what? Deferred operand. Yeah. All right. Let's actually go like that. So here's the bosom. Here's the bosom context. Here's the bosom context. Here's the label. Deferred operand. Labels. Deferred operand. Deferred operands. So we're gonna go and just rename everything. Operands size, and it's gonna be deferred operands capacity. So yeah, this is a BASM context. This is label. This is a deferred operand, and here we're gonna have. Goddamn. Okay. So it's gonna be just BASM then. It's gonna be BASM find label address. So this is what it's going to be. Find label address. Bosom push label. Bosom push deferred operand. Right. So, and yeah, that's the set of the operation. That's the set of the operation that we're going to have. I probably have programmed too much in Java since I don't find the names long at all. Probably. That's probably what happened to you. But fear not. Just by watching my stream long enough, you can be cured from this sickness. I'm joking. Let's do the following thing. It's gonna be deferred operands capacity. I'm gonna replace that, and there we go. So what's gonna be the next thing? Label table. We'll have to replace label table with just bosom. Boom. Replaced successfully. And maybe we need to find query replace LT. We're gonna call it just bosom. Okay. So also anonymous. Okay, unresolved jumps. So we need to rename unresolved jumps to deferred operands. Should we press it forward? Boom. There we go. Anything else? Unresolved jump need to be renamed to deferred operand. Boom. There was only one instance of that. Okay, so let's find label table to bosom. Press it forward. Cool. So here I would like to return it to just bosom. Yeah. Cool, still works. Now in BM, I still want to find all of these cases of LT and rename them to the cases of bosom. I think that's a good enough situation. So that means here, I see. So now I can do query replace this with bosom. Boom. Is it gonna work? Is it gonna work? Cool. Almost there. Bosom. Compiler assisted refactoring. Wait a second. Label table find. God damn. So here's the thing. I changed the definition of these functions. Right. But, I mean declaration. But it never actually asked for definition. Do we have a special flag that makes GCC complain when you have a declaration but don't have a definition? Does anyone know? Does anyone know? GCC declaration without definition. So because that's exactly what happened. No warning for function declaration different from so what do we need here? Missing prototypes. Yeah. So this will serve the job, but this is the other way around. It basically complains about definitions without declarations. And it's kind of like the same situation. So we have some functions for which we don't like change the declaration, and that may trigger it actually. Declarations without definitions is a linker issue. No, not necessarily. This is not what I'm talking about. I'm talking about this. No previous prototype. This is what I'm talking about. I don't know what you're talking about, but I'm talking about this. Okay. So this one is a bosom find label address. I don't want to enable everything because it's kind of a pain in the ass. Bosom push label. Yeah, bosom push label. And this one is gonna be bosom push deferred operand. Okay, now we're talking. Bosom push label. Bosom push deferred operand. Bosom find label address. Uh-huh. Oh, but that results in these kind of situations. Okay, nice. So that means, god damn it. So because of that flag, now I have to do this bullshit. Wait, I don't have to. Wait. I can just mark them as static. If I mark them as static, I think this flag does not... Yeah, I was right. So, yeah, it's kind of interesting. Okay, so that worked. That worked. I think I refactored everything. But what's interesting is that now I need to check how building everything works. Yeah, you have a similar situation. It has to be static, and this thing also has to be static. Cool. Now, if I build examples, cool. So, if I take a look at the bosom, fibbm, it still works. I can now do BME. This is the input, this is the limitation, 69 instructions, everything still works, and we're ready to do a committee. So what exactly we did here? I refactored the names. Refactor the types for bosom translation context. There we go. I'm gonna push that right into the repo, and we're ready to make a pull request. How about that? Isn't that amazing? So we finally finished the feature of labels for assembly. We actually have a pretty powerful assembly language for our virtual machine. Actually, virtual machine. It's not virtual machine. So we have support for instructions, labels, comments. Looks pretty great. There are differences between container and virtual machine. I guess. I think they're completely different things. So I don't think they're even comparable. You can probably implement... first of all, when people say virtual machine, they could mean absolutely different thing. So, for example, JVM and VirtualBox are not particularly comparable. So the main difference between JVM and, for example, VirtualBox is that VirtualBox is an emulator for an existing machine in reality, whatever the fuck reality is supposed to mean in this particular context. JVM is a non-existing machine. It's a like virtual machine that doesn't exist, and it was designed specifically for one language. It's actually a very complicated topic. Right, so first of all, we don't really know what you mean by virtual machine in your questions, right? We need to clarify what you mean by virtual machine first. And second of all, what do you mean by a container, right? So containers could be implemented using a virtual machine, or they could not be implemented by using a virtual machine. Maybe they use some sort of like a mechanisms of the operating system that don't include virtualization. So first of all, we don't really understand what you mean by container and virtual machine. And second of all, regardless of their definitions, I don't think they're comparable. So it's a really difficult question. You asked a very difficult question, in my opinion. I know nothing about computers. All right, so let's make a pull request. Okay. Implement labels for assembly. Thanks you. You're welcome, I guess. Again, I know nothing about computers. Oh, I just realized that I don't have a continuous integration for this project, but at least we can take a look at the changes, at how many changes we made to make it possible. That's a lot of changes. Not gonna lie. Not gonna lie, that's a lot of changes. Okay. So let me go back and merge this pull request. Boom. First try. How about that? Merge the pull request. First try. Get coder. What else do we have here? What else do we have? We have things probably related to bytecode. Yeah, there's also there's a lot of interesting stuff that I will try to tackle. No checks, first try. Yeah, I know. Have you guys heard about NaN Boxing? No. Have you guys heard about it? I'm not even sure if I'm gonna actually use NaN Boxing in my virtual machine. but I kind of want to research if it's going to be applicable. How do you spell it? You box with NaN. NaN Boxing. Yeah. So let me fetch the latest changes, and then we're going to try to... First I'm going to P, and then I'm going to explain what is NaN Boxing. Right. So here are the changes. NaN Boxing, that's a legit question. Yeah, so I'm gonna explain it a little bit better. So essentially, roughly the idea. So what is a NaN? How many of you know what is a NaN in IEEE 754 arithmetics? So it's a special value of floating point, specifically according to IEEE 754, that represents not a number. So it's not a correct number. But what's interesting is that there is huge amount of NaNs. NaN is something for which the exponent is set to all ones, as far as I know. Right. So, but what's interesting is that these bits don't matter. If all of the exponent bits are 1, it doesn't matter what these bits are, it's going to be none. The whole number is going to be none. So that means you have these bits for different nuns. So what that means? You can make a NaN and store your values inside of none. You can use doubles to store some additional information inside of a double, and it's not going to be a correct double. So you box a value inside of a double, right? So that's basically what it is. So this is what a NaN Boxing. What's interesting is that is used quite extensively in dynamic languages like JavaScript. So what JavaScript does, if a value is not a NaN, it is treated as floating point number. If it is none, we throw away exponent and sign and look at first 4 bytes. First 4 bytes indicate the type inside of a NaN, right? So, and then, depending on the type, we interpret these bits, not bytes actually, these bits differently. So usually for NaN Boxing, people use thank you. People usually use 64-bit floating points rather than 32 bits of floating point for NaN Boxing. So let's actually Google them up. Maybe we can find them here. 64-bit float. I want like a similar, double precision floating point format. Okay, so it's actually kind of cool, not gonna lie. Let's actually open this thing. Yeah, cool. Essentially, it's the same idea. So exponent all 1, it's none. First 4 bits is a type. So what's interesting is that you have 52 bits to represent your value inside of it. So you waste 4 bits for the type, 52 minus 4, and you have 48 bits for your value. So if you need to represent very big values, right, you can just store a pointer in 48 bits. This raises the question, how that even feasible on 64-bit architectures, right? Because on 64-bit architectures, the pointers are 64 bits. How can you fit 64-bit into such a small number? Well, there is a trick. As a matter of fact, the x86 64 vendors, they actually made a shortcut in implementing 64-bit architectures. x86 64 virtual address space is gonna iGooduk knows that. So the AMD 64 architecture defines 64-bit virtual address format, of which the low order 48 bits are used in the current implementations. So there is no a single 64-bit processor that actually uses all 64 bits for virtual address. They all use exactly 48 bits, and this is exactly how much we have. So you don't need more than 48 bits to represent an address on 64-bit architecture. This is dumb, funny, and depressing at the same time, and also genius at the same time. And there you go. I just explained you the whole idea of NaN Boxing. This is the whole idea, seriously. And people actively use this in dynamic languages, as specifically, this technique is used in V8, the main JavaScript virtual machine. So yeah, who needs 64 bits? So I guess it was just easier to implement at 48. But in the future, the specification, as far as I know, actually allows you to take this shortcut. So, but in the future, you can extend that. But I don't know how the languages that use NaN Boxing are going to extend that. But even with 48 bits, as far as I know, you still can address a lot. You can still address 256 terabytes of the memory, which is quite a lot. I mean, majority of people don't need more than 256 terabytes. Why use NaN boxes rather than just use a full int64 with all the upper bits and flags? Flag bits, sure, you can probably do that, but what if you need to represent the floating point inside of the integer? How are we going to distinguish between floating point and integer? So if you do NaN boxing inside of a double, it's actually quite easy. Is your number a none? If it's not a none, okay, I'm gonna just treat it as a double right away without doing anything. If it's a none, I'm gonna just unbox that value and just use it right away without any modification. It's actually super convenient. Like with using integers, you just have to do more work with transformations and stuff like that. NaN boxing allows you to do less transformations to achieve the desired result. It's just like less work. You just strip away whatever you don't care about, and there you go. Here's your data. Why is it a none if the exponent all ones on IEEE 754? Because IEEE 754 said so, but I don't remember their reasoning. Okay. Hive mind. All right, so before we're gonna try to... by the way, I never implemented NaN boxing in my entire life. So actually a lot of things that I do in the streams I do for the first time. But before I'm gonna try to tackle that, I need to pee, so it's quite important. God coder needs to pee. Yeah. All right. So it's gonna be 2 minutes. Let's put 2 minutes. Enjoy. Thank you. I'm gonna definitely enjoy that. Trust me. All right. Let's make a small break, and you guys have fun. Yo, what is up, epic cooters? Sorry. I don't know how is suffering his back sitting on this ergonomic chair. It's actually fine, I guess. I'm not even leaning on the back usually. I don't know. I need to actually observe myself. Anyway, so what we need to do, we need to try to explore the idea of NaN Boxing and see how we can implement all of that. So did we fetch all of the changes? I think we did. All right, so let's go. Observe Mr. Streamer. Yeah. So the NaN Boxing is the fourth issue. So let's create it. Create fourth branch. I'm gonna also create a separate executable called nan.c, and I'm gonna just do experimentations with the NaN Boxing there. So the description actually should be enough for me to implement that. So what's the purpose of your boxing in your Birch VM case? I'm Pepega. Essentially, Birch should support different types, I think. Like, for example, floats, or like do mathematical operations on floats and on integers, at least. Maybe we can also support the pointers, right? So because we have a stack, right? We have a stack. So BM, right? And right now we have just words which are 64-bit integers, right? But I also want to be able to push not only integers there, but floating points, right? And I also want to support for operations on floating points. I also want to be able to push pointers there, right? So I need to be able to push all sorts of things there at some point. Well, to be fair, I need to push only three kinds of things: integers, floats, and pointers, right? So, and again, as I said, I'm not even sure if I'm gonna end up using NaN Boxing. It's just like I heard that people use it for some cases. I never used it before, never even tried to implement it. I wanna like kind of explore it and see how it's gonna go. A string could be a pointer, actually. Is there a data type for 48 bits? No, there's no one, but you can feed it into 64 bits. Essentially, during unwrapping, you can just feed it there. To be fair, like you can just using bit operations, you can just cut off sign and exponent and just cast it to 64-bit, and that could be 64-bit without too much conversion. Yeah. It's like a single bit operation plus cast. You can also use pairs of 32 and 16-bit numbers. Yeah, I guess. As I already said, I'm not sure if I'm gonna end up using all of that, but I definitely need to be able to push floats on the stack as well. Right, I definitely need to be able to push floats, and I want to be able to distinguish between floats and integers, so there should be some sort of a bit that allows me to do that. You're wrong, by the way. You can create 48-bit number. You mean using the bit fields? Is that what you mean? Maybe. Yeah. I see what you mean. All right, so let's try to implement this thing. Before we're gonna try to implement that, I kind of wanna implement a function that will help me explore things. Print bits. So, and what we're gonna accept here, we're gonna accept an array, actually a pointer to uint8 t. We're gonna accept bytes and bytes size. There we go. So essentially, what I want to be able to do is to print bits like double pi. Pi. Give me pi. Thank you. Thank you, Google. Very cool. Right. Pointer to pi converted to uint8t, and then size of pi. Right. And I basically want to print the bits of this thing. So for now, I'm not going to print the bits. I'm going to just print the bytes. I'm gonna just print the bytes and just gonna do it like that. So it's gonna be print f x space bytes I, and then at the end of all of that we're gonna print the new line, and let's see how it's gonna go. So I need to build this entire thing. Let's put it to none, and none is gonna be pretty straightforward. None doesn't depend on BM right now, it's just like a temporary executable. Let's try to build all of that. And okay, it does complain about this thing not having a prototype, which is understandable. Cast pointer from integer of different size. Well, yeah, I can always... Oh yeah, it has to be like this. Yeah, there we go, now we're talking. And this thing has to be avoided because I don't have anything here. Cool. Alright, so now I can try to print the bytes of the pi number. Let's try to print the bytes of the pi number. NaN... this is not how we do that. There we go, here are the bytes. We might as well actually make it look a little bit better, hopefully, by doing something like this and making it capital. Come on, Emacs, make minus b. And here they are, alright, so now I guess I'm gonna try to print the bits of each and individual thing here. To be fair, I could have actually EAFB. Yeah. So this is we are on a little engine machine. Is x86 little engine? x86 little. I think it is. I think there's not that many like big engine, little engine. Okay. So that means the least significant ones are at the lowest addresses, so they're at the left. They're at the left, and yeah, that means I have to first of all look at these things in a reversed order, right? And also interpret the bits in the reversed order, if I understand everything correctly. Whew, okay, so let's try to tackle that and see how it's gonna go. I'm gonna start with int, and we're gonna start with this thing. So it's gonna be int. Greater than 0, and we're gonna go in the reversed order. But maybe we could have... let's do it like that. And for a particular byte, bytes I, we're gonna do what? We're gonna do this thing 4 times. J0, j less than 8, plus j. So we need to do that 8 times. And essentially what we're doing, d byte 1, and that will print it in a reversed order, actually. Right, it will print it in a reversed order, which means that I actually want to do that like this, I think. Okay, and maybe then we can split each individual byte by a space, and then we're gonna by a space, and then we're gonna split each individual thing here by a new line. Will that give me the desired thing? I think it didn't do that. Yeah, because after checking that, yeah, I need to convert it into a 1. Is there any way to do that? I think I can do it like that. Yes. Bits are not in the reversed order, are they? Maybe they're not. So let's try to do that the other way then. This is going to be that byte 1, and then we can do byte 1. So okay, that looks like true. Another thing we can do here, we can try to take a look at something like 1, right? And 1 is going to be just this. 1, 1. Does it look like 1? Okay, what about -1? I think -1 is the most interesting one because it's gonna be like this: -1, -1. We can actually create a macro that inspects a number somehow. Inspect number. Inspect number. Okay, so print bits of integer. We can try to do that, but well, all right. So we're gonna do it like that. So this is gonna be the name. Name. Well, name doesn't really matter. Doesn't. Ignore the chat. Ignore the chat. So, okay, -1. Okay, it is incorrect. So, it is in fact incorrect. So let me think. Right. So if it's a little endian, right? Little endian. So that means I need to iterate them in a reversed order. But if I don't iterate them in a reversed order, is it gonna do something else? I don't think it's a great idea of doing it like that, right? Oh, by the way, I think I'm an idiot. I think it has to be -1. I think it has to be -1. Okay. So this one is already interesting. Okay, this one is already interesting. All right, and if I do something like this, that's very interesting. God, I wish I could just ignore the chat. You guys are distracting me so fucking much. Holy shit. Okay. All right, so this is -1 until it's 0, and okay, looks okay. So I still don't quite understand why it would be like that. So let me see. I don't want to actually do this thing. I just want to take a look at the bytes one more time. Okay, the bytes are correct, actually. The bytes are correct, which is nice, because that's exactly what I would expect, roughly. We can also make them look like 02. Hopefully that will align them properly. Yeah, they look good. They look good. I like how they look. Nice, nice, nice. So now speaking of the bytes, so something is really wrong with the bytes. And I'm not quite sure what, right? So bytes. Because if I try to do this thing, it should be in a particular order, right? It should be in a particular order. But it's not what I... Okay, I see that these particular beats are reversed because this is like a negative sign. Negative sign. So it should be in the opposite order. So that means initially this thing was correct. And it doesn't really reverse anything. Right? It doesn't really reverse anything because... Okay, so that means I have to do that from the opposite order, I think. Holy shit, you're so helpful, Mr. EDMakes. Does anyone have any other obvious things to say? Like, maybe somebody is gonna tell me that my code is written in C. Does anyone want me to tell that? Holy shit. The backseaters are fucking crazy today. Holy shit. Like, do you genuinely think that you're helping me by saying that? Like, do you really think? Or you just intentionally try to piss me off? Like, I cannot tell, like, seriously. Like, sometimes it feels like people just intentionally try to piss me off instead of, like, genuinely trying to help. Holy shit. Alright. So, that works now. So... Zozin, your code doesn't work. Well, no shit, Sherlock. Holy fuck. Okay. Cool. Are you telling to me, James? If you're telling that to me, you're chill the fuck up. 1 hour. Okay. So. Don't tell me to chill. So, what we're gonna do here. So now we have bits. And now we can see all of that, which is actually kind of cool. So because now we can clearly see everything. So as I already said, I really want to have like a special macro that like allows us to inspect things. Inspect double. Let's actually call it inspect double. Yeah, inspect double, and it's gonna have a value. And do we need to have a name? I think I also want to provide the name here as well. I think it's gonna be useful. Right. So and then we're gonna create like a special thing here. Double. So it's gonna be name equal value, right? And we're not gonna evaluate a thing here. Okay, name, and then print bits. There we go. You int 8t, and it's gonna be pointer to the name and the size of name. Cool. Inspect double. And on top of that, I also wanna maybe have some sort of like a printf, right? Printf, where I'm gonna actually do something like this, and we're gonna just put the value here. So, and that should enable me with doing the following thing. Inspect double. Holy shit, Emacs, stop. Emacs is as helpful as chat, not gonna lie. Okay, so and then I can just do something like this. What's funny is that I think I won't be able to put semicolons here. And E, okay, minus. Yeah, it has to be something like this then. There we go. That's actually pretty cool. I wish I could like probably space it out a little bit more, like better, like T. Yeah, it looks a little bit better. I like that. So we can now clearly see how it goes. You can clearly see. Encoding doubles, sort of, rather decoding, more of a decoding. Yeah, do I need that? So everything looks okay. To be fair, I could have actually done something like this: 7 greater or equal than 0, then minus minus, so I don't have to do that shit anymore, right? So we could have done it like that. It's the same shit. Pretty cool. So maybe we want to try to do things like infinity. So to achieve like infinity, I think you simply divide by 0, right? You divide by 0, and there you go, we have an infinity. What's funny is that Okay, so then we can have minus infinity. It's minus 1 divided by 0, right? So it's the same as infinity, but with this thing. And now let's try to do none. So who knows how to achieve none? Who knows how to achieve none? You essentially divide 0 by 0. So that's how we achieve none. So here's the none. And here is the thing that reveals what's the difference between nonce and infinites, right? It's that additional bit, I suppose. And how many bits do we have here? It's kind of interesting. So if I query replace space with nothing, right, and how many zeros here? We have 51. 51. I would like to actually space them out a little bit better, right? Is this an UC thing? I don't remember division by 0 possible. Well, it's actually a pretty old thing. You're probably confusing floating point division and integer division. Floating point and integer division are completely different. So in case of an integer division, you will get the exception on the level of CPU. As far as I know, you will get like a literal CPU interrupt. Yeah, which will, you know, in majority of situations, it will crash your program, I think. In case of a floating points, nothing's gonna happen. You're just gonna get a none instead. Do I understand it correctly, by the way? I think division by 0, like it's literal CPU interrupt. Okay, so where's the double? Yeah, I want to take a look at this thing. So it's a 52. Oh, it's literally 51. All right. So, and then how many bits we have here? 12 bits, right? Okay. 64 minus 12 is gonna be 52, right? Oh my god, I'm an idiot. 52. Looks like 52, yes. It is in fact 52, and yeah, essentially. First bit of exponent is signaling quite none. This one, right? Okay. Mantis. Okay, we'll have to research that a little bit further a little bit later, at some point. Okay, this one is actually very interesting. So dividing 0 by 0 results in a negative none, as you can see. How can we get a positive none though? Do we have to divide it by minus 0? Could be. It's still a negative one, which is kind of interesting. But in any case, how can we check if something is a none? I'm gonna make a really wild guess and basically assume that you need to construct minus 0. Minus 0 is not a none, it is a valid thing. Minus 0. Yeah, it is a valid thing. It's literally just one bit here. Literally just one bit here. Like, tabs don't help here to align things properly. Kind of, it's funny how tabs actually make it even worse. So, yeah, I think it's just a little bit better. I wish I could just align that like properly, but it just doesn't make it. Okay, well, we can do another thing. We can actually put like a new line here and tab it appropriately, so maybe that's gonna be, there we go, that's way better, I think. So yeah, maybe even four spaces. Why not? It's just way better. Oh, okay. Cool. Yeah, how can we check that something is a none, right? So I'm gonna make a wild guess and just check for these 3 bits, right? And we know that the amount of bits here is 12, right? So that means I can do something like 12 minus 1 and then shift that 52 times, right? 11, no, 12. You sure about that? The first bit of Mantissa. Alright, so is that one? So we have 11 of them. Okay, 11. Okay, you're right. I see. So that means it's something like this. Okay. And the first bit signaling the quiet NaN. Okay, I see what you mean now. Thank you so much. Okay, cool. So that means we have to do 11 and 52, and yeah. So that's the mask that we need to use to check things with, right? To check things with. And how are we gonna do that? What's interesting is that this is the value, right? I can apply this mask to the value, and if the result is equal to this mask, I can assume that it's a NaN, right? I can just straight up assume that it's a NaN. So let's try to define this thing. Let's try to define it, and it's going to be a NaN mask, right? It's going to be our small little NaN mask. Thank you, Denkesvinkek. Thank you so much. All right, I wonder if I can do a pretty interesting thing where I would do... Oh, I have an idea. What if I always cast it to double as well? That would be actually pretty cool. So then I can inspect. We don't even need this name. I feel like we don't need this name. I think it's kind of redundant if you ask me, chat. Right. Yeah, I guess. And then I can do like minus thingy here. Alright, so I think we're ready. Yeah, it's kind of redundant. So, and the thing I want to do here, I want to check out the NaN mask. What do you want to check specifically using mask? I want to check if I constructed mask correctly, and I think I didn't. Alright, so warning left shift count width 52. Okay, so these things has to be like LL, I think. I think that's what we have to do, right? Alright, so when something went horribly wrong, as you can see, it is not what I think it is. Your macro is still using name, yes, because you need to have a variable here of some sort. Okay. I wonder why it doesn't really work the way I want it to work, because maybe the type is not particularly known. Is that could be the thing? Doing 6040. Or maybe I'm missing something. I just want to see. You need a binary representation, not conversion. Yeah, I think it performs the conversion. Ah, I see what. Ah, god damn it. Yeah, I see. So that means I actually have to pass the type as well. So that's the problem. I have to pass the type. Okay, so I can do that. Right. So this is going to be double, but for that one it's going to be uint 64, and because of that we can actually do something like this. Inspect value, right? Because it's not only double now. It's not about the double anymore. Right, value. Inspect the value, and there we go. This is what I was talking about. Look. This is what I was talking about. But we still use it as a double. Whatever. So this is the mask I was talking about. Yeah, it's LF, but I mean, whatever. So we don't need this thing anymore. Cool, cool, cool. NaN mask, and we can easily check if the thing is NaN or not. Like if you have double X, right? You wanna. Is this an epic IEEE stream now? Yeah, it is. It kind of is. So as you can see, we're looking at the representation of the doubles and stuff like that. I'm trying to find a way to inspect whether a number is none or not. By the way, I need to make a small break. Just a second. I need to make a small break. If X... That was the way to check. Maybe. Alright. Alright, let's make a small break and you guys have fun.
The lights were on and I thought you might be home. I wasn't sure.
Yo, what's up? Welcome back. Welcome back. So we could probably check x not equals x for none, but we'll have to manipulate bits anyway, so I just thought maybe we can try to do that on the bit level as well. Alright, so this is a NaN mask, and essentially we'll need to take a pointer to x, and we'll have to convert it to, well, suppose you int 64t pointer, then we'll have to dereference that thing and apply the mask, like NaN mask, to all of that. I'm not sure if I'll have to do this kind of thing. So NaN mask, and after that, if the result is equal to NaN mask, well, that means it's probably an indication that this is a none. Maybe. So let's check. Is NaN 0? Like, let's put it this way. Yeah, let's put it this way. It's gonna be none down there. I didn't copy this thing properly, probably. Let's go back here. And we can just do yes, new line, and otherwise no. Right, it's gonna be like this. Cool. And something is wrong, so this is just a warning here. And L value required on apparent. Oh boy, so this it has to, you cannot just take a value, right? So that means this thing has to be a function, unfortunately, right? Specify that none should have non-zero significant, meaning that testing on it. Yeah, I know that. So it's a case of Zozin. Why are your code is not finished? Okay. Zozin, your code is not finished. Okay. Why is your code not finished? Finish your code with a single keystroke. No, it is not that. So what's interesting is that if you do something like this, it is yes, but again, it is not enough, because something like -0 is also gonna be, no, it's not none, but the mask itself could be that actually. So if I do something like this, uint 64, so it's gonna be nonsense. I like how Emacs autocomplete, like I made a typo and autocomplete and it gave me nonsense. It's nice. I like that. I like that. Okay, so if we take this thing right by itself, all right, if we take it by itself, and then I convert it to pointer to the double, right? Pointer to the double, dereference it. It will tell me that it is in fact a yes, but if we take a look at the representation and what the runtime of C tells us, it tells that it's a 0, and we're getting closer to the fact that is not enough to check that like for NaN mask, right? So we're getting closer to making our code more, you know, finished, right? Making our code more finished. So this is not enough. And another thing we need to do, we need to okay, so yeah, I'm gonna do a branching right now, and yeah, probably there is a way to do that without branching, but again, I'm in the middle of writing code. But of course, feel free to tell me how wrong I am by doing these things with my unfinished code. All right, so I kind of want to drink some water, but if I start drinking water, I'm gonna get really cold. I'm gonna make a cup of tea. Does anyone have any questions? Does anyone have any questions while I'm making a cup of tea? I'm making a cup of tea. Where are all of the backseaters? Ask me something. You are if block is empty. Interesting. How do I stay motivated? I don't. I'm never motivated to do anything. Why your if block is empty on the line 29? That's a good question. Thank you for asking. Does anyone have any other questions, maybe? So the quality of my answer depends on the question. So yeah. What actually are you planning to on virtualizing? x86 again. It's yet another case of people not realizing the virtual machine can mean two different separate things. There's a virtual machine that is trying to emulate one of the existing architecture in real life, and there's virtual machines that are non-existing machines specifically designed for programming languages like JVM. Or maybe I don't understand what you're trying to ask. I'm not virtualizing x86. It's an imaginary machine. Is this really a virtual? Another case of the same situation. Okay. So this is a virtual machine designed for a language. That's what it is. So it's not trying to design to emulate any existing architecture which runs operating systems or anything like that. It's a virtual machine in sense of a JVM, for example. JVM is also a virtual machine, and on a JVM you cannot run Windows. Yeah. Is it still Birch VM? It was never Birch VM. What the hell are you talking about? System virtual machines versus process virtual machines. I guess you can separate them like that. That's an interesting way of separating them. Does JVM have multiple backends though? I'm pretty sure it does have multiple backends. Depends on the definition of backend. Alright. So I need to take a look at the NaN definition. To be fair, I feel like I'm forgetting it. NaN IEEE 754. So let's see it. Let's take a look at Wikipedia, the reliable source of information. Right. Example, bitwise single precision, whereas as most often ignored, x is a sequence of non-zero values. The first bit from x is used to determine the NaN, quiet NaN or singling NaN. So, all right. Floating point. Operations as the ordering comparison normally propagate the quiet NaN. Most floating point operation and singling NaNs signal the invalid operation exception. The default exception action is then the same as QN. Alright, nice. Quickly goes to edit Wikipedia to give wrong info. Ah, that's a god gamer move. Okay, so I'm gonna go to the kitchen, right, and turn on the kettle, and you stay here, watch the stream, don't go anywhere. If you go anywhere, I'm gonna signal all of your NANs. So, yeah, it's gonna be real good. Don't go anywhere. What's up, Epic Gamers? That was good. What BM stands for? It stands for virtual machine. It does in fact stand for virtual machine. Quiet NaN. Quiet NaN or QNaN do not raise any additional exceptions as they propagate through most operations. The exceptions are where the NaN cannot simply be passed through unchanged to the output, such as in format conversions or certain comparison operation. Special form of NaN that when consumed by most operations should raise an invalid operation exception and then if appropriate be quieted into QNaN that may then propagate. Okay. So, nice. So maybe I'm misunderstanding something. I feel like I'm misunderstanding because chat keeps confusing me. I should not read the chat when I'm doing this kind of stuff. Okay, NaN, check if double is none. Let's actually straight up Google it up And C, Java is none. How do I test if something is a none? Okay. I see. So we also have quiet, not quiet. So the first bit is used to indicate whether something is quiet or not. Oh my god, it jumps around. It's difficult. Where was that? Where was that? So, is that from Mantissa or not? To know whether this thing is from Mantissa or not, I need to go to the temp and then find IEEE 754, 32 bits, single precision, floating point, and what's the amount of significant of the exponent. So we have 8 bit of exponent. Okay. So how many bits we have? 1, 2, 4, 1, 2, 3, 4. This is an exponent. Okay. So that means we have that, and that's the only thing I wanted to check, to be fair. So the first bit from X is used to determine whether a quiet or signaling. And when it is quiet, is it equal to 0 or not? Most often ignored in applications. So that means this should be enough. And some people were saying that this is not enough, and from the back of my head I remembered that it was not enough because like I vaguely remembered about signaling, non-signaling. But okay, so that was yet another case of me reading the chat and being confused by the chat. So I shouldn't read the chat and, you know, try to make sense of it, because people have no idea what they're talking about. Cool, nice. So, all right. Sometimes you have NaN in library, then you need to be quiet. Okay. So, here's the thing we can do. So here's the NaN, right? And then we can try to extract this value, right? I want to also do a pretty interesting thing, essentially. Printf 1, 2, 3, 4 is NaN equal like this. Yep. And is NaN. Well, yeah, I'll have to convert that to value. Right, I have to convert it to value. To name, actually. I have to use name. I have to use name. I just want to see what's gonna happen. So, and this is the problem, right? So infinity is also considered a none, right? So that's kind of the problem here. Infinity is also considered a none. So that means if I take a look at these bits, so it's at 11 characters. Okay, so, and exponent all ones is an infinity. Minus infinity is just exponent all ones with a signed 1. But NaN is going to be non-zero thingy, right? Do I understand that correctly? I think I do understand that correctly. IEEE 754 NaN versus infinity. Infinities and nuns. Signal separation. Arithmetic involve infinity. Okay, I think my tea is ready, by the way. I think my tea is ready. A signal in NaN represented by any bit pattern between this or between... Okay, this is not really helpful. Quiet is represented by... okay. All right, so infinity. So we know for sure. So this has to be 11 bits, and again I need to keep like single precision and double precision nearby because I keep forgetting about this. So essentially NaN is just like any non-zero thing here. So that's quite important. Does C library has anything for checking for NaN? C check if double none. Does C have anything in the standard library or, you know, stuff like that? Is NaN. It's literally called is NaN. Okay, that's cool. CPP reference. So I just want to double check if... Okay, cool. So it even... I didn't know that it has that. Cool. Because I rarely work with floating points, so that's actually cool. Alright, so this is my is NaN, right? So this is my is NaN, and we're gonna have theirs is NaN. Let's see. Okay. So theirs is NaN. That's cool. So it tells that 0. So that means we have to take a look at the mantissa and also check if it's non-zero or right. Okay, so we're gonna check that. We're gonna check that. And how can we extract the mantissa? Extracting the mantissa should be pretty straightforward. So, well, it's not really mantissa, right? It's called fraction. Okay, so let's call it fraction. Define fraction mask. All right. So we're gonna do a 52. 52. Come on. This and then -1, and there you go. Here is your fraction mask, and we can extract this stuff like that. So maybe it would also make sense for me to extract this value to uint64t, like y. So and then I can do something like this, and then you know, fraction mask, return fraction mask greater than 0. I think that's what I want to do here, like, right, greater than 0. And what's interesting is that we can do something like this, where we do, right? So do NaN mask if equal to that, greater than 0. Okay. And our thing didn't work. Nice. Not equal 0. I think that's what it has to be. 52 bits. What am I missing here? Classic C. And yet it didn't help. Okay. I mean, fraction mask is okay. So then I can check if it's so what am I missing here? What am I missing here? It feels like I'm missing something very obvious, to be fair. But I'm not sure what exactly. Right. So, does anyone see any mistake here? Actually feels like looks okay to me, right? Like I don't see any mistake here. And yet, if I recompile it, the result of is none. Maybe, wait a second, maybe I'm doing something, like it's really strange, like why? Something really obvious, like something dumb, like as usual. Is there LL missing? Don't tell me that this is the case, please. Holy shit, this is so bad. This was the case. Oh my god! Can C die already? Can this language die already so we don't have to suffer this kind of stuff? Jonathan, please, open beta. Open beta, we need open beta. The entire civilization is collapsing. Jonathan, you don't understand. Like, the entire civilization is collapsing right now, right here, because you don't release Jai. We need it. We're suffering, we're dying here. Holy shit. Anyway. So, John Blow single-handedly collapsing civilization. Yes. Okay. What do we have? Okay, so this looks consistent and whatnot. Shouldn't compiler warn overflowing costs? It should, but it didn't. I guess. I don't know. Okay, good. So we can try to do other things. So which essentially means that, well, we can also easily do infinity, right? So we can also easily do infinity. So here is another mask that we can define. It's going to be sign mask, right? And it's going to be essentially 63, I think. Yeah, it's just 63. And we can easily check for infinity and stuff like that. Is infinity, right? Double X. And in this particular case, I think what we're trying to do is check for this thing being that, and another thing, we should take the fraction, not the fraction but the sign, right? Sign, and it should be equal 0, and that's the way we can check if it's a positive infinity or negative infinity. So in C we have isInf, right? We do have isInf. Do we have isAnIf? Okay, so what's the opposite of as isInf? What's the opposite of it? Is there even an opposite of it? Or it checks for any infinity? No, for negative infinity. How do you check for negative infinity? C, negative, inf. It doesn't matter, right? So it doesn't matter then. Okay. So that means for infinity, we just don't have to check the sign then. It's the same function. Okay. Alright. So, what's funny is that this entire thing, by the way, could be very slow because it may introduce a branching. I think in some situations this kind of shit may introduce branching, and maybe to not do that we could try something like this. Are you using GUI Emacs or CLI GUI one? But maybe it doesn't really matter in this particular situation, so yeah, doesn't really matter. Okay, so now we know how to check for all of these things. So we're learning things, chat. We're learning things. People asking in the chat, Zoizin, why don't you use NaN from the standard library? But what if I don't have a standard library? What if I don't? And I don't even know how to do any of these things. I know how to do these things. Do you? You see? We're learning. This is educational content. That's what it is. We're here to learn things. Not to just use some wimpy libraries, okay? We want to get to the level so we can implement those wimpy libraries ourselves. Did you have a blueprint for all of this or a rough idea of how to do it to start? No, I didn't. I just Google things. Imagine you're on a deserted island, no libs, exactly. Oh, by the way, npm I mean, it probably has isNaN. Wait a second, it does have isNaN. I even remember that. It does, yeah, there we go. Yeah. Just doing fucking damn it. Classic npm. Oh, by the way, can I find your mom on npm? Wait a second. There is something that is not on APM. How do you upload to npm? Your mom was so big. They couldn't put it on npm. Anyway, I think like we need to create like your mom npm package that depends on all of the packages in npm. I think that's a cool idea. What do you guys think? So basically you try to do npm install your mom, and it basically fills up your entire disk space. I think it's I think it's a cool idea. Okay, so we have that. You can find your mom proper English. Oh, okay. So there is your mom. Well, let's take a look. Your mom. Alright. So this package name is not currently in use, but okay. You can adopt this package. Okay, so there's a second one, your mama. The random your mom joke generator. That's actually cool. I like that. Keywords your mama. Okay. I was about to give it a star. Holy shit. Anyway. So now let's actually try to take the fraction of a NaN and extract its type. Right, and extract its type. So how can we do that? Get type maybe? It could be something like do you actually remember all the code? Yes. That's a good question actually. I was never asked that question before. Thank you so much for asking. So yeah. So we're gonna use only first 4 bits, right, for this thing. And that means I'll have to do something like this, 4, right, and then -1 to actually turn it into like 4 numbers. And then I think I have to do like 52, yeah, I'll have to do something like this, 48LL, and this is gonna be my type mask, right? It's my type mask. Do you remember all the code in the Linux kernel? Yes, I do remember all the code in the Linux kernel. Thank you. Okay, so here's the type mask, and after that, I think I can try to bring it back to 48 and then return something. Yeah, so this is a get type. Okay. Value mask. Let's actually call it box type, right? So because we're doing NaN Boxing, right? So, and what I need to do here is 48 LL and then -1, right? Then -1, and that will enable me with getting the value. Okay, value. Might as well actually u in 6040. Right, this one is also going to be in line. U in 6040 get value, and it's essentially the same thing. Double X. So we also will need to do something like set type, and so on and so forth. Right? Set type, set value. So this one is going to be get value, and what's funny is that we don't even need to change anything here. This is literally it, right? So you just take that value, and that's it. Get value, get type, and so on and so forth. So nice one, Kodev. Oh shit. Okay, implicit declaration. Expansion of a macro. Okay, we don't have is none. Oh shit, that's actually very interesting. Holy fuck. So it cannot properly inline it or something, so static. If I make it a static. Oh yeah, that worked now. So speaking of, yeah, there is LL here. Okay. Speaking of, very interesting. So get type, get value, but now we also need to be able to construct all of that. What do you usually use Lisp for software, for making software? All right. So what I'm thinking, if it cannot inline, just drop in a static. Well, yeah. Codev, thank you. Thank you so much for 3 months of Twitch Prime subscription. Thank you, thank you, thank you, and welcome to our epic NaN Boxing Club. Right. So what we're doing here is a NaN Boxing, essentially. Hopefully, like, I know that it's not really pretty, but I'm gonna just get the gist of this idea, and once we have something at least working, we can try to optimize it, make it more concise, more pretty, and stuff like that. I made your mom NPM package. Cool. I'm really glad for you. LL Boxing. Yes, that's what it is. So I guess we need to be able to also set the type, right? So we want to do it like this: uint 64t set type, right? So it's going to be a double x, right? And we're also going to accept the type like this, right? And it's going to be just like 4-bit value that you want to set here, right? 4-bit value. And how are we gonna do all of that? Well, I'm thinking maybe we're gonna take the pointer to this entire thing. It's gonna be a pointer, but we're gonna convert that pointer into this kind of pointer, and I'm gonna keep it like that. Why? There we go. So afterwards, so this is the type mask, right? This is the type mask. So the type mask is actually not particularly convenient because one of the things I need to do here for the type mask to work is to bring it back like this, then apply it to the type, right, to get rid of any of the garbage in the type. So basically I'm gonna cut off the rest of the bits, and once I have that, I need to bring it back to 48 bits. You see what I mean here? Bring it back and then do something like this. Oh, by the way, and this has to be like double then. Right, so it's not multiplication, but can I do it like that? I think I should be able to do it like that. To be fair, like, it doesn't have to be like this. I could just make it like that and then convert it back. Right, and then what we can return here, we can take a pointer to this thing, to that, and just dereference it like that. So this is how we can set the type. Right? So this is how we can set the type. Nice. And another thing we need to do, we need to now set the value. So let's actually double check if this entire thing compiles. It still compiles, but there are some warnings which I'm not sure about. Implicit declaration. I think we need to do something like math. Where is NaN located? I'm pretty sure is NaN located somewhere in the maths. I don't see here. Here it is. Yes. Math.h, and if I try to do that, it does not complain about anything anymore. Absolutely beautiful. Love it so much. Okay. Now, so we can set the type, we can get the type. Now we need to set the value. Maybe I need to get rid of this inlines. It's kind of getting bad. There we go. Okay, go. So get value, let's do get set value. That's right. Set value. We accept the double, and the value is gonna be this. Here is the value. Welcome back, old man. I'm gonna do the similar thing here as well. And what are we doing? We take the value mask. Value mask doesn't have to be moved. Doesn't have to be moved anywhere. We're just applying it to the value to cut off any garbage. We're just cutting off any garbage, and then we're applying it to y. Right? We're applying it to y, and then I'm just returning the y. Just returning the y is gonna double this and this, and this is how we set the value. So we can get the value, we can set the value. So, and another thing I need to do, I need to be able to turn a value into a none. So I need to be able to take the zero double. By the way, zero double, I never checked the zero double. Is zero, literally zero, is all zeros? I think it is. I think it's literally all zeros. So if you take a look at that, yes, it's literally all zeros. So that means I can take that. Oh, that's cool. And also take that and start filling up the value, the type, and so on and so forth. This is actually cool. I like that. I really like that. So so here we take the type. Do we really need the type? Yeah, we do need the type. Then the value, and I also want to have some sort of a label. How can you remember all the codes with my brain? All right. So, and what's going to be the label? I want to kind of remove some of these things. And I remember that in a standard library. Hello, Lokim Junior. Welcome. I really like your nickname. It's a very good nickname. So NaN. What is NaN? What does NaN do? Convert the implementation defined character string into corresponding quiet NaN value. How do you use that? Oh shit. Wait a fucking second. What the fuck is this shit? So this is gonna be pi. And instead of this stuff, instead of this, I'm gonna just use label, and I can put this thing here. Oh my god, Emacs, stop Emacs, please. Alrighty, so this is pi and this is that. What is another thing I would like to inspect? I would like to inspect something like NaN 0, and this is what I'm gonna have, NaN 0. I don't know what's that supposed to mean. Torlenor, thank you so much for your subscription. Thank you. Thank you. Thank you. 2 months, by the way. Thank you for 2 months of subscription. Really appreciate it. Alrighty, so that's very interesting. That's a very interesting way of doing that. But yeah, is that like really a none? So I want to take all of these ones and see how many ones we have here. So if I take a look at that, it's 12. So all right. So if I take a look at the into this thing, so it's going to be 1. It's still. Oh, I see. Oh, I see. I see. Okay. Okay. So you see it's now 1. It's just actually, we can store the value there. That's actually pretty cool. We can store the value there. So, and it could be also 2. You see what's going on? See what's going on? So NaN 2, and this is essentially what performs the NaN boxing for us. I think that's kind of cool. I think it's kind of cool. But we always need to set that type thingy. We always need to set that type thingy. Okay. So I want to do something like set none. Maybe make none. This is what I'm gonna have. So a thing that will make me a none. I'm gonna start with I guess I'm gonna start with just 0 here, right? It's gonna be like this, is just 0. And I'm taking a NaN mask. Well, to be fair, like you can just literally return none mask like this, right? NaN mask, and just return. It shouldn't be NaN mask, by the way. Should be X mask. That's what it should be called. It's quite important. So we literally take it like this, then convert the pointer to the double, and then dereference it, and there you go. We made, actually we made infinity. We made infinity, technically, right? But by setting type to something very specific, right? By setting type to something specific, we can make different nonce and shit. I learned about NaN tagging from Luajit. So they call it NaN tagging there, like, because from what I heard, usually people call it NaN Boxing. Yeah, somebody gifted you a sub. We recently had a lot of sub gifted, so it's kind of interesting. Thanks everyone who gifted the subs. Really appreciate it. Yeah. So this creates an infinity. We can even confirm that, for example, by doing something like make inf, right? So it's just basically NaN mask, and well, yeah, okay. This is not the best way to confirm that. We can do something like this LD, make infinity, right? LF, that's what I wanted to say. Yeah, there we go. It gave us infinity. It gave us infinity. So, and the next thing we need to do is to set a particular type for the infinity. Right, set type. So, and what kind of types can we have there? So, since 1 bit already signals whether it's quiet or not, right? So we only have like 3 bits to indicate the rest of the stuff. So what kind of like types we can have? I want to have like a type integer. Type integer, and I don't know. Let me think. Type 0. Type 0 is going to be literally just 3, right? Type 1 is going to be type 0 plus 1, 2, 3. So 2 to the power 3 for 8. I think we can do it up to 8. Yeah, I think we can do it up to 8. So 2 to the power 3, I guess it's 8. It's actually not a bad idea, man. We can do it like this. It also has to be like this. Now, so when we get the type, we also have to be... Okay, so I think we're ready to try something like this, right? So we make the infinity, and we also set the type for the infinity to, for example, like type 0, right? I don't know, 0, whatever. And nothing happened. Yay, I'm super happy. So if I try to do something like this now, yeah, so it is correct. So it's infinity, right? It gave us infinity. But setting the type for some reason didn't work, right? So you cannot do type 0 anymore. So the mistake could be in the type itself. It could be in the type itself. Define type, right, plus n, or in the set type. Okay, so we can have x, we take type mask, we bring it back, we apply it to the type, we bring it back there, and then, I see, like this. But that's not enough actually, because you have to clean everything first. Yeah. Alright. No, it's not that. Don't worry about it. So what we have to do here is to negate type mask and join it with y, like this. To clean up the whole type, we need to clean it up. And then we have to join it with the rest of this stuff. So this is what we need to do here, right? And now if I try to... okay, I managed to successfully set the type, which is actually exactly equal to none. So we managed to put a type there. So I'm gonna put it like 0 here. I think we managed to do that. So let's actually put a couple of things here. So this is gonna be 1, this is gonna be 2, this is gonna be 3. And now if I try to do that, there we go, we're successfully setting types. So the type is these 3 bits, right? And we're incrementing them, adding more and more stuff there. Yeah, it's not bad. It's not bad at all. What are you trying to build? I'm trying to build a NaN Boxing. Have you heard about NaN Boxing? It's kind of amazing, I'm not gonna lie. Alright, so let me get rid of all of these things, and we're gonna iterate uint64t, and it's gonna be something like x0, x less than 8 plus plus x. Alright, and yeah, we're gonna put x right here, and I'm not gonna change the level, whatever. Alright, so if you look at these 3 bytes, we keep incrementing these 3 bytes up until we actually fit everything, and all of these things are like actual nuns. So they're actual nuns. So we can set value, we can get value, and so on and so forth. But yeah, setting value is actually also incorrect because of the same reason, right? So what we need to do here, we need to take the value mask, we need to invert it, and we need to clean up the value of this thing. There we go. So we clean it up like this, and then we're setting it and applying it like that. Cool. So now, on top of that, I should be able to also set a value. Right, so right now, as you can see, for all of these things, value is 0. It's not set to anything. We can set that value like this. So it could be something like 1, 2, 3, 4, 5, 6, 7, LL. And if we take a look at it, there we go. So all of these things are nuns, as you can see, all of them are nuns. They have different types, and they have the same value that we set it for it, right? You see? I think it's going quite well. So we can store up until 8 types in a nun. We can store up until 8 types. Even though we have 4 bits for the type, 1 bit is taken by marking none as being silent. How long did it take to learn coding? Well, I'm still learning it. So it's not like you make it sound like it's a finishable process. You never stop learning coding, because the coding itself, whatever that's supposed to mean, of course, keeps changing as well. New things are being discovered, invented, and so on and so forth. So you're learning for the rest of your life. So you're never gonna stop doing that. That's the problem. Maybe that's also a blessing. Some people kind of like it. I do like it personally. Technically, yeah, I could for additional information, but I'm not sure, like, it's kind of making it difficult to use, to be fair. Alright, so, and now, to be fair, I can bake the type into this thing. Alright, so that's actually pretty cool. We don't really need isInf, I think. I think we don't use it anywhere. So we can make an infinity no previous prototype. Oh yeah, this thing can be static. Static. Yeah, I just need to mark all of them as static to get rid of these warnings, because we're not using these things outside anywhere. And for the isNone, I don't think we need isNone, right? Because we have that in a standard library, so I'm gonna just keep it like that, right? So we can just use the standard library anyway. Whatever. Get value, defined but never used. Okay. So, alright, I think we have all of the basic operations to start doing this kind of stuff, and I don't know. So how can we utilize all of that? As I already mentioned, I wanted to store so far 3 kinds of values: integers, doubles, and pointers. That's it. So let's try to implement that. So we have all of the building blocks here, right? All of the building blocks. Let's implement that. So we're gonna have something like is double, right? So, and you provide the value double. And how we're gonna do all of that? So if return get type x, right? We get the type. That gives us int, and I compare it to type double type, right? So it's gonna be like this, and we're gonna define double type as 0. So then we're gonna have integer type. Integer type is gonna be 1, and then we're gonna have a pointer type is gonna be 2. Cool. So, and this is what we're gonna do here is, yeah, it is a scope reflection. Integer type is going to be integer. Yep. It's so full of hacks It's unbelievable. Pointer type. Okay, so we have something like this here. Amazing. We can easily check if something, yeah, is that. Now, as double, well, this was easy. I mean, I kind of feel like I need this function for like a complete set of functions. I mean, I feel like I need that. U in 64. You can. Okay, so it supports only unsigned, but we also need signed one, right? Integer double x, and essentially what we're doing here, we're just trying to return the value, right? We get the value out of x, and that's it. Pretty straightforward. So, and then we also want something like this, s pointer, right? Double x, return get value of x, and maybe you can just do like that. Oh, and by the way, I forgot a very important thing. First of all, this thing has to be none. Oh shit, I'm an idiot actually. First of all, this is how we check that. This is literally how we check that. It's not a none, it's double. So it's double if it's not a none. It's integer if it is a none, and we take in a type and it's integer type. And what's fine is that you don't need this thing. So in case of a pointer, it also has to be a none, right? It has to be a none. And by the way, if I take a look at it, oh wait, is none. Is okay. Okay, cool. Is none, integer type, is none, pointer type. As double, pretty straightforward. Get value, pointer, cool. Will all of that compile? Will all of that compile? Okay. Define but not used. Okay, so it just complains about not used. So I need another functions. Box double, right? It's pretty straightforward as well. Okay. Next thing. Box integer. So then we make an infinity, right? We make an infinity. We set the type of this thing to be type of integer type, right? And then we also set a value to x, and that's what we return here. So this is how we work with all of that. And box pointer, void star x, same situation pretty much to be fair. How long have you been coding for? Check out my FAQ. So it's actually answered there. I think for like 15, 16 years, I don't remember. Set pointer type, and we'll have to cast this entire thing in like this. Okay, so it doesn't complain about anything. And what's up, Donko? Welcome to the stream. How are you fucking doing? Welcome. So we're gonna have this thing, double values. So yeah, we're gonna have like, let's say, values capacity is going to 156. Values capacity, size t, values size 0. All right, and what I want to do now, I want to box a bunch of things. Oh, you actually missed this XXS tech aspect. I was actually explaining what all of that means, but yeah, it's too late, I'm sorry. So box double, let's actually box pi. Can I get some pi? So box pi. Another one, we're gonna box integer. So this one is going to be 1, 2, 3, 4, 5, 6, 7, 8, LL. And we're going to actually box pointer, and we're going to have a pointer to like double X something, something, something like this. And this is going to be literally the pointer to this thing. And we're going to box all of that. So then I'm going to iterate through each individual value, each individual boxed value. Right, and I'm gonna print the following things: is double d is double equal d, I is double value I. Another thing is gonna be is integer. Another thing is gonna be is pointer. Okay, so we're checking everything simultaneously. That's what we're doing. Let's try to compile that. And something went wrong. Where is the error, by the way? Here's the error. I don't see any errors here. Value C. Okay. Oh, what's up, Shazawak? How are you doing? Very glad to see you. Okay, and I forgot new lines. I forgot new lines. There we go. Okay. So first value, this is quite important, by the way, chat. It's quite important. Let's actually separate it by new. So we added to the list 3 values. The first value is double, the second one is integer, the third one is pointer. Right, then we know that the first value is double but not integer, not pointer. Second value is not double, not pointer, but integer. And the third value is not double, not integer, but pointer. As you can see, we can quite successfully identify the class of a boxed value inside of that thing. So I think it's quite cool. Okay. So, and then they're not pointers. Well, we're talking about NaN, like NaN Boxing. We're boxing different kinds of values within a double using the IEEE 754 representation of double. So any like floating point is represented in a particular standardized format, right? So it has a sign, it has an exponent, and it has a fraction. So, and floating point numbers, they have a particular state which is called not a number. It's when all of their exponent bits are ones and their fraction is not 0. Yeah. So their mantissa, or whatever people call it differently. So is not 0. So we are basically taking advantage of that. So if double is a none and not a number, we have the whole fraction to store some additional information in. Yeah. So we use like first 4 bits to represent the type of the value we store there. And we use the rest of the bits in a fraction to store the exact value. So we can store integers there, and we can store pointers there. You never heard about NaN Boxing before? It's actually quite surprising. Well, I mean, yeah, people who usually know about NaN Boxing are dynamic language developers, right? So people who do not develop dynamic languages, like scripting languages and stuff like that, they usually never heard of it because it's like a common trick there. Yeah. So, and we can just store that like additional information there. Well, I mean, yeah, it was implemented before, but I'm doing that because I want you to learn something, right? All right, so let's actually try to do some things. For example, I want to assert that value 0 is equal to itself when unboxed. So that should be okay. So we can even print OK here. We can even print OK here. All right, so something went wrong. Something definitely went wrong. Assert, yeah, I need to include assert. Assert.h. Do we have anything else? Value C, excuse me. Do we have anything else? Where is the another? Oh, okay. So, okay, this is okay. All right. So the second value, I'm gonna try to interpret it as an integer, and I'm gonna try to see if it's equal to itself, like here. Is it equal to the value that we actually put into the box? Okay, it is equal to itself. Cool. And the second value should be equal to the pointer to x. Right, so we do that, and then pointer, right? So these are the values that we boxed into the double, right? We boxed them into the double, and let's see. And everything's okay. Okay, so that's actually pretty cool. We can try to break something, like this. Yeah, it actually breaks, so... yeah, that's pretty cool. I don't understand what you're talking about, Crazy Wolf, I'm sorry. Alright, so we have this NaN Boxing situation, and one of the ideas I have, right, one of the ideas I have is go to BM, and instead of words on the stack, use NaN boxes. Use these boxes. You see what I mean here? And when we are implement like plus operation, and for example we have two values on the stack, we can inspect their types, and for example if one is integer and another one is double, we can take that integer, convert it to double, and the new result is going to be double. So we can have like automatic conversion to different stuff and like that. And we also can check for pointers, and yeah, do some pointer arithmetic. Zozin, you have too much energy. Really? Well, yeah, okay, so we'll probably have to wrap up the stream, but we managed to implement NaN Boxing of some sort, I think. I think we managed to do that. Anyways, so can I try to do the following thing? So this is gonna be like that. Let me put it into the pi. So this is gonna be like this. So this is gonna be the ultimate test of this stuff. So this is gonna be pi, box pi, like this, right? And then we're gonna try to box this value and try to I think this is how I have to do that. Right. I'm actually already tired. Box integer. And it's gonna be pi here, pointer as a pi. And this one is gonna be box pointer. Alright, so this is gonna be our test here. We're gonna get rid of these things. And we're gonna get rid of these things. And everything's okay. So we have some things that are not used here. It's kind of strange that I haven't used stuff. Alright. Okay, so this is gonna be the test, right? This is gonna be the test. Is that a good NaN Boxing implementation? I think it's quite good. Like it serves its purpose, like we can set the values and stuff like that. Probably don't need print bits anymore. Not really sure if we need them. Yeah, we're gonna remove that. So the next step I need to do, I need to extract that to like a separate header, or maybe make it a part of BM. And yeah, cool. Let's commit that. So it's gonna be git ignore NaN, and there we go. Add prototype for NaN Boxing. Implementation of NaN Boxing. There we go. I'm gonna push that right into the repo. So I guess we're gonna integrate this NaN Boxing into the virtual machine, excuse me, tomorrow. Yes, I think instead of Vodus, I want to do another virtual machine stream tomorrow because I kind of enjoy doing this thing. So yeah. But on Thursday, by the way, on Thursday we're gonna do Advent of Code. Yes. So basically, I decided that on Thursdays we're gonna start solving Advent of Code, and I was thinking whether I want to start solving like starting from 2015 or starting from 2019. So, and here's my idea. I heard that Advent of Code throughout the years was steadily becoming worse and worse. So I decided to go in an opposite direction and experience how Advent of Code becomes better and better. So essentially, on like every Thursday, we're gonna solve Advent of Code, like 2019, then 2018, 17, and so on and so forth, and actually experience how it becomes better over time. Right. When we ran out of Advent of Code, we're gonna try to find something else. So the Thursday is gonna be like a competitive programming day where we solve challenges. Maybe I'm gonna finally try CTFs or crack me's or stuff like that. So, and yeah, and on Friday we're gonna do random one-off stream. So okay, yeah, today was actually pretty good stream. We did a lot. We expanded our assembly. Now we have like a proper assembly, and we also implemented NaN Boxing. But we didn't integrate NaN Boxing into the virtual machine, but we implemented the NaN Boxing itself. So tomorrow we're gonna continue doing Advent of Code, and we're going to try to integrate that NaN Boxing into virtual machine, so our virtual machine will be able to support pointers, integer arithmetic, a double floating point arithmetic, and combined integer floating point arithmetic. So, and yeah, that's it for today, boys and girls. That's it for the day. Thanks everyone who's watching me right now. I really appreciate it. Have a good one, and I see you tomorrow. Tomorrow, as I already mentioned, we're gonna continue developing this thing. Check out our schedule for more information on what projects we're working on. I'm gonna update the schedule after the stream. Right, check out our VODs channel where we upload all of the previous streams. This stream is going to be there, but tomorrow we upload them on the next day. I think I'm going to create a separate playlist for virtual machines specifically. So maybe working on that virtual machine is going to be like a separate series we're actively working on because it looks interesting and people like it. So yeah, I'm going to keep doing that. And also check out our Discord server for offline discussion with the community. And let's maybe raise somebody. So who can we rate? Is anyone doing anything interesting? Is anyone developing virtual machines? Okay, so let me see. Meta-circular evaluators. What's that? What is meta-circular evaluator? I don't really know what that is. Twitch is stuck. Okay. Game Dev Pro C++. It's Unreal Engine though. I want something low level, creating to the game template in Rust. Huh. Sounds interesting. I want to try something else. Oh, it's French. Well, I don't speak French, unfortunately. Oh my god, like making a Git client. Huh, in C++, by the way. Making a Git client in C++. I'm GUI.
Look at that.
That's a, okay, that's an insta rate. Sure. Yeah, that's our guy. Let's read him. There we go. Get ready for the raid, boys and girls. Get ready for the raid, and I see you all tomorrow. Love you.